Scientists admit something is very wrong with our universe. For years, scientists believed the universe worked like a perfectly written equation. Every star, every atom, every motion followed rules that could be predicted. Physics wasn't just a subject, it was the language of reality itself. But lately, that language has started to sound broken. Could something be very wrong with our universe? The cracks in the cosmic model. Measurements of the universe's expansion don't agree. Quantum experiments produce results that make no sense. Some of the most trusted theories in modern science, the ones that built our understanding of space and time, are starting to fall apart. The universe, it seems, isn't behaving the way it's supposed to. That's when things turned unsettling. Because the deeper scientists looked, the more it began to feel like something was seriously wrong. Not with their equipment, but with reality itself. Imagine spending your life studying how the world works, only to realize that the rules you trusted might not be real. That's what's happening right now. It's as if the universe has been quietly rewriting itself behind our backs, bending laws we thought were unbreakable. At first, the clues were subtle. Astronomers studying distant galaxies found that they were moving faster than the laws of physics allowed. No one could explain it. Then, quantum physicists started to notice that tiny particles, the basic building blocks of everything, were acting like they could sense when they were being watched. They didn't behave like matter. They behaved like information. Each new finding made the picture stranger. Time and space, things we once thought were solid and absolute, began to look flexible, almost like illusions. The universe, the grand structure we assumed was made of matter and energy, might actually be made of something else. Something invisible and far more mysterious. And the most unsettling part, every time scientists tried to solve the puzzle, it only got more confusing. The equations that once explained everything now contradict each other. Observations that should match don't. The closer we look, the less sense it makes. Like zooming in on a digital image until you start to see the pixels and realizing the picture was never real in the first place. For decades, science has promised that the universe can be understood if we just look hard enough. But now, even the best minds admit that something doesn't add up. The universe seems to be hiding something. And whatever that something is, it's big. We thought we were close to understanding everything. The Big Bang, dark matter, time, energy. But maybe we were never close at all. Maybe what we've been calling reality is just a small, limited version of something far beyond our comprehension. And that's what makes this moment so powerful. It's not just that scientists are finding mistakes. It's that the very framework of reality, the one we live in, trust in, build our lives on, is starting to look unstable. What if the laws of physics aren't laws at all, but temporary rules in a system we don't fully understand? What if space and time are just illusions, tricks of perception? What if reality itself is thinner, stranger, and less solid than we've ever imagined? For the first time, science isn't just searching for answers, it's questioning the stage on which all answers exist. And in that quiet realization, as theories crumble and familiar truths fall apart, something extraordinary has happened. Science, the one thing built on certainty, has finally shivered. Because somewhere, buried deep beneath equations and galaxies, there's a truth that refuses to fit. A truth that whispers that maybe, just maybe, our universe isn't what we think it is. For most of modern history, scientists have lived by one golden rule, that the universe makes sense. Maybe not immediately, maybe not easily, but eventually, with enough patience and math, everything could be explained. And for a long time, that seemed true. The Standard Model of Cosmology, also known as LCDM, Lambda Cold Dark Matter, was the crown jewel of that confidence. It was the grand equation that supposedly explained everything, from the birth of the cosmos to the motion of galaxies. It told us that the universe began in a fiery explosion, expanded over billions of years, and continues to stretch outward, guided by invisible forces we only partly understand. For decades, LCDM was untouchable. It predicted the age of the universe, the way galaxies form, even how light bends around massive objects. Every new observation seemed to confirm it. Scientists celebrated it as the closest thing we had to a theory of everything. The math worked, the models fit, and for a while, it felt like we had cracked the code of reality. But then came the cracks. They didn't appear all at once. They started as little inconsistencies, numbers that were off by just a few percent, odd readings that didn't match predictions. Small things, easy to brush off. But those small things refused to go away. The first major fracture came from something called the Hubble constant, the rate at which the universe is expanding. It's a number that defines everything. How old the universe is, how far galaxies are, how long light has been traveling. Every major telescope on Earth and in orbit has tried to measure it. The problem? They can't agree. When scientists measured the expansion rate using light from distant galaxies, the way it's done in cosmology textbooks, they got one number. But when they measured it by studying the faint afterglow of the Big Bang, known as the cosmic microwave background, they got a completely different number. And both were measured so precisely that the odds of it being a coincidence are practically zero. It's as if the universe is telling two conflicting stories about its own age. At first, researchers thought it must be human error, a calibration problem, a data glitch, anything. But as technology improved, the numbers only grew clearer and further apart. What started as a minor tension became what cosmologists now call the Hubble tension, and it's tearing the very fabric of cosmology apart. Then, there's the dark matter problem. For decades, astronomers noticed that galaxies spin faster than they should. Based on gravity alone, most of them should have flown apart long ago. The only explanation was that something invisible, dark matter, must be holding them together. So scientists did what they always do. They went looking for it. They built massive underground detectors, particle colliders, and space telescopes. Decades later, they've found nothing. No particles, no signals, not even a trace. It's like searching for a ghost in an empty room. Some physicists began to whisper the unthinkable. Maybe dark matter doesn't exist at all. Maybe the laws of gravity themselves need rewriting. But rewriting gravity means rewriting everything, from black holes to the birth of stars. Still, the clues kept piling up. Next came the early universe anomalies. The Big Bang model predicts that the universe's first galaxies should look small, dim, and chaotic. Messy clouds of gas just starting to form. But then the James Webb Space Telescope came online and saw something no one expected. Right there, in the supposedly infant universe, just a few 100 million years after the Big Bang, were massive, perfectly formed galaxies. Mature systems that shouldn't exist so early. It was like finding skyscrapers in a newborn city. The data was undeniable. Either the universe grew up impossibly fast, or our entire timeline of cosmic history is wrong. The more scientists looked, the more strange patterns appeared. Some stars seem older than the universe itself. Light bends around empty regions of space as if pulled by invisible hands. The cosmic background radiation, the leftover echo of the Big Bang, contains mysterious cold spots that shouldn't be there. At first, all these things were dismissed as small errors, but the errors multiplied. They began to form patterns that pointed to one unsettling possibility. Maybe the model we've trusted all this time isn't just slightly off. Maybe it's fundamentally broken. The standard model of cosmology, the map we've used to understand our entire existence, might be missing something enormous. Even worse, some of the inconsistencies seem to connect. The Hubble tension, dark matter, early galaxies. They might not be separate mysteries at all, but symptoms of one deeper truth we haven't yet seen. It's like tugging on a loose thread and realizing it's unraveling the whole fabric of reality. And here's where things get truly unsettling. The LCDM model relies on two invisible components, dark matter and dark energy, that together make up about 95% of the universe. That means everything we can actually see, stars, planets, life, you, me, makes up less than 5%. The rest is invisible, untouchable, unknown. We've built our understanding of reality on things we can't even detect. And for a long time, that was fine, as long as the math worked. But now, the math doesn't. The numbers are rebelling, the patterns are breaking, and the story of the universe no longer adds up. Scientists don't like saying this out loud, but a quiet panic is growing. The deeper they look into space, the stranger it gets. The deeper they look into matter, the more it dissolves into probabilities and information. Somewhere between the infinitely large and the infinitely small, the truth of our universe is slipping through our fingers. What if the reason our models are falling apart is because the universe isn't what we think? What if it's not made of matter and energy at all, but of something entirely different? The cracks in the cosmic model are not just errors on paper, they're signs. Signs that the foundation of reality itself might be far more mysterious, far less stable than we ever imagined. And if those cracks keep spreading, they won't just change what we know about the universe, they'll change what we believe about existence itself. When equations lose their meaning. For centuries, equations were the closest thing humanity had to truth. They were clean, certain, and absolute, the one language the universe never seemed to argue with. You could write an equation in chalk on a board in Tokyo, and it would hold true in a galaxy millions of light years away. Math was the bridge between imagination and reality, between the unseen and the undeniable. But lately, that bridge has started to crack. The numbers don't add up anymore. The universe, that dependable machine we thought we understood, has stopped following its own script. Precise calculations that once predicted how galaxies should behave now produce answers that don't match what telescopes actually see. Equations that described gravity, energy, and time down to the smallest decimal no longer align with the data. And the worst part? No one knows why. It began subtly. Scientists would run their models expecting everything to match, and it almost would, but not quite. A decimal point too high here, a strange variance there. At first they blamed their tools. Maybe the telescopes needed recalibration, maybe the algorithms were off. But as the technology improved and the inconsistencies grew sharper, one phrase began to echo through research papers and late-night discussions. Something fundamental is wrong. Those 5 words have appeared again and again, from teams studying the expansion of the universe to particle physicists probing the quantum world. It's not just one field, it's happening everywhere. Take gravity, for example. We thought we knew how it worked. Einstein's equations have guided us for more than a century, predicting everything from black holes to the bending of light. But now, when we apply those same equations to the largest structures in the universe, they fall apart. Galaxies spin too fast. Clusters of stars move as if pulled by forces we can't measure. The math that built modern physics suddenly looks incomplete. Then there's quantum mechanics, the realm of the very small. Its equations are beautiful and terrifying, describing particles that can be in 2 places at once, or change behavior depending on whether they're being observed. But even that beauty has begun to fracture. When physicists combine quantum mechanics with Einstein's theory of gravity, everything explodes into nonsense. The equations break, not figuratively, but literally. The numbers spiral into infinities that have no physical meaning. It's as if 2 perfectly logical systems can't coexist in the same universe. So which one is wrong? The answer no one wants to admit is, maybe both. That realization is shattering, because math has always been the tool we use to make sense of everything. Math gave us rockets, computers, medicine, and the ability to map the stars. But now, at the highest levels of physics, math itself seems to be rebelling. Imagine trying to describe a dream using numbers. You can measure, predict, analyze, but the dream keeps shifting, changing shape every time you think you've defined it. That's what studying the universe feels like now. It's as if reality itself has started to behave like something alive, unpredictable, fluid, and far stranger than anything our equations can contain. Across the world, Research teams are quietly admitting it. We might have reached the edge of what our math can describe. The equations that once told us everything may no longer be capable of explaining what's actually real. That's why so many scientists are starting to ask a different question. One that sounds almost philosophical. What is reality made of? For generations, we assumed the answer was simple. Matter, energy, space, and time. The ingredients of existence. But now each of those seems to be slipping through our fingers. Matter dissolves into invisible energy. Space stretches and bends. Time slows down and speeds up depending on where you stand. Even the vacuum of empty space isn't really empty. It seethes with unseen energy and virtual particles popping in and out of existence. It's becoming harder to believe that reality is a solid physical thing. It behaves more like a pattern, a kind of information written across a deeper layer of something we can't quite name. That's where the conversation is heading now. Cosmology has hit its limits, and physics is being forced to look inward, not just at the stars, but at the structure of reality itself. What if the universe isn't made of matter at all, but of data? What if space and time are just byproducts of something more fundamental, like a computer simulation, or a cosmic code that runs beneath everything we see? It sounds like science fiction, but that's exactly what some of the most respected scientists are now exploring. When equations stop working, it doesn't just mean our math is wrong, it means our assumptions about reality might be. That's where the new frontier begins. Not in galaxies or atoms, but in the hidden architecture of existence itself, a place where numbers lose their meaning and something deeper takes over. Because maybe the universe isn't a machine after all. Maybe it's a message, and we're just beginning to realize we've been reading it wrong. The universe that shouldn't exist. It's hard to believe the universe could be an accident. When you look at how perfectly everything fits together, the stars that burn at just the right temperature, the planets that orbit at just the right distance, the atoms that hold just the right balance of charge, it all feels a little too precise, too lucky, almost intentional. And that's exactly what has begun to bother scientists. The deeper they study the cosmos, the more they realize that everything about it seems impossible, not unlikely, impossible. The universe, by all calculations, shouldn't exist in the form we see it today. The odds are so small, they make winning the lottery look like a sure thing. Yet here we are. To understand the problem, you have to start with the basics. The laws of physics. Every star that burns, every breath you take, every atom in your body is governed by a few unchanging constants. Gravity, the speed of light, the strength of electromagnetism, and so on. These numbers define the rules of reality. If even one of them were slightly different, not by a lot, but by a fraction of a fraction, the universe would collapse into chaos. If gravity were just a little stronger, stars would burn out too quickly for life to form. If it were weaker, galaxies wouldn't have formed at all. If the charge of the electron were off by even 1 part in a trillion, atoms wouldn't hold together. And if the expansion rate of the universe after the Big Bang had been even a touch faster, everything would have drifted apart before stars ever had a chance to ignite. In short, we're living inside a cosmic miracle that shouldn't be possible. For decades, scientists dismissed this as coincidence. There's no reason to believe the universe should care about us. We just got lucky. But as more and more coincidences piled up, luck started to sound less like an explanation and more like an excuse. Because the more precisely we measure the universe, the more delicate it appears. It's as if reality is balanced on a knife's edge, a hair's width away from nothingness. And that's not how random accidents behave. The Big Bang itself raises another question. Why did it produce such perfect conditions for order to form? Explosions don't create harmony, they create chaos. Yet somehow this one set everything in motion. Stars, galaxies, chemistry, life. The odds of that happening naturally are so vanishingly small that even hardened skeptics are starting to wonder if something else is at play. Some physicists have started calling it the fine-tuning problem. Others call it cosmic design. But whatever name it goes by, the meaning is the same. The universe appears to be rigged for existence. And not just any existence, one that allows for observers like us to notice. This is where the story gets stranger. Some researchers believe the only reason the universe looks fine-tuned is because we exist to see it. If it hadn't formed this way, we wouldn't be here to ask questions about it. It's called the anthropic principle, and it's the scientific way of saying, of course it looks perfect. We're the ones lucky enough to be inside it. But others aren't satisfied with that. They argue that this explanation feels like a loophole, a way of avoiding the bigger question, why does anything exist at all? To answer that, new theories have started to emerge. Ideas that push the boundaries of science itself. Some suggest that our universe isn't the only one. Maybe there are countless universes, each with different laws of physics, and we just happen to live in the one where everything works. It's called the multiverse theory, and it paints reality as an infinite sea of possibilities, each one slightly different from the next. It sounds elegant, until you realize there's no way to prove it. We can't see beyond our universe. We can't test it. For all we know, this might be the only one there is. That's when the whispers begin again, the ones scientists don't like to say too loudly. What if the reason everything looks designed is because it is? Not in the old religious sense, but in a deeper, more unsettling way. What if the universe isn't a random explosion, but a structured system, a simulation, a construct, or even a form of consciousness expressing itself through physical laws? It's a question that makes most scientists uneasy, but the evidence keeps pulling them toward it. The mathematical precision of the cosmos, the strange way reality behaves like information, the fact that everything seems tuned to support order, all of it suggests that maybe, just maybe, the universe is more than just matter and energy. Because if it were truly random, it shouldn't have produced stability. It shouldn't have produced beauty. It shouldn't have produced us. Every constant, every particle, every law appears to work together as if following an unseen plan. The more we look, the more deliberate it feels, like a code written with purpose, or a song composed with perfect rhythm. And that's the mystery that's shaking science to its core. The equations fail, the models crack, the data defies logic. Yet the universe remains calm, balanced, impossibly precise. It's as if we're staring at something intelligent, something aware, something that wanted to exist. The universe that shouldn't exist does. And the closer we get to understanding why, the more it feels like we're not just studying the universe anymore. We're being invited to understand it. Quantum reality, when observation creates existence. If there's one place where the universe drops its mask, it's in the world of the quantum, the microscopic realm beneath atoms, smaller than protons, neutrons, and electrons, where the rules of reality start to melt. Down there, things don't behave like they're supposed to. They don't follow logic, they don't obey gravity, and sometimes they don't even seem real until someone looks at them. It's the strangest idea science has ever faced, and it's true. At the quantum level, particles don't act like tiny billiard balls bouncing around in space. Instead, they behave like waves, fuzzy clouds of probability, existing in many possible states at once. A particle isn't here or there, it's both and everywhere in between. It doesn't decide what it is until someone, or something, measures it. This bizarre truth was revealed by one of the most famous experiments in physics, the double-slit experiment. Here's how it goes. Scientists shoot tiny particles, like electrons, toward a barrier with two slits. On the other side is a detector screen. If the particles behaved like solid objects, they would pass through one slit or the other, forming two clear lines on the screen. But they don't. Instead, they form an interference pattern, a series of waves, as if each particle went through both slits at the same time. That alone is strange enough. But then the scientists tried something even stranger. they placed a detector to watch which slit the particle went through. The moment they did that, the interference pattern disappeared. The particle stopped behaving like a wave and acted like a solid object again. In other words, the simple act of observing it changed what it did. This isn't science fiction, it's physics, proven, repeated, and still unexplained. Somehow the universe seems to know when it's being watched. That one experiment changed everything. It suggested that reality doesn't exist as a definite thing until it's observed. Until something, or someone, looks at it. The universe is just a cloud of possibilities, waiting to become real. Think about what that means. It means the act of seeing might actually create reality. The universe might not exist out there, independent of us. It might only come into focus when consciousness interacts with it. Einstein hated this idea. He famously said, "I like to think the moon is there even if I'm not looking at it." But quantum mechanics quietly replied, "Are you sure?" Because in experiment after experiment, the same strange pattern appears. Observation, awareness, changes what happens. Light acts like a wave until you measure it, and then it becomes a particle. Atoms behave differently when watched. Even entire systems of entangled particles seem to communicate instantly across space, faster than light, as if reality itself bends to awareness. It's called quantum entanglement, and it's another mystery that refuses to fit into the old framework. Two particles created together remain connected, no matter how far apart they are. Change one, and the other reacts instantly, even if it's on the other side of the galaxy. No signal travels between them. No force connects them. They just know. Einstein called it spooky action at a distance. But that spooky action has been proven over and over again. It's not magic. It's how the universe works. And here's where things get really unsettling. If observation changes reality and entanglement connects particles beyond space and time, then maybe the universe isn't made of physical stuff at all. Maybe it's made of information, a kind of invisible code that reacts to consciousness. This idea has led to a growing theory among scientists called it from bit. The phrase was coined by physicist John Archibald Wheeler, who proposed that everything, matter, energy, even space-time, emerges from information, not the other way around. In other words, the universe might not be a machine, it might be a program. Think about that for a moment. Every star, every atom, every thought could be the product of informational processes running beneath the surface of what we call reality. Matter could simply be data rendered into physical form when observed by consciousness, like pixels lighting up on a screen when you look at them. And that raises a haunting question. If the universe is like a simulation, who or what is observing it all? Some scientists believe this observer could simply be consciousness itself, not yours or mine, but a universal awareness embedded in the fabric of existence. Others think consciousness is a natural product of this informational system, a kind of mirror the universe built to look at itself. Either way, it suggests that consciousness isn't an accidental byproduct of matter. It might be the opposite. Matter might be a byproduct of consciousness. That idea changes everything. It means the universe didn't just give rise to awareness. Awareness might have given rise to the universe. It would explain why the laws of physics are so fine-tuned, why quantum particles behave as if they're aware of being watched, and why reality seems to exist in response to attention. Maybe everything around us, from galaxies to the ground beneath our feet, is a manifestation of something deeper, a reality that only becomes real when experienced. Quantum physics doesn't just challenge what we know, it challenges how we know. It blurs the line between science and philosophy, between observer and observed. The more we try to measure reality, the more it seems to depend on us for its shape. Maybe that's why the universe feels so personal, so oddly synchronized, so aware. Because, at the smallest scales, awareness might be the engine that keeps everything running. We used to think we were small, tiny specks floating in an endless, indifferent void. But what if it's the other way around? What if the universe itself depends on us, not as rulers, but as participants in its unfolding? In the end, quantum physics isn't just about particles, it's about perception. It tells us that reality doesn't exist in full until it's seen, that observation, attention, consciousness are not passive acts, but creative ones. Maybe we're not separate from the universe at all. Maybe we're the part of it that knows it exists. And if that's true, then the line between observer and creation disappears, leaving only one truth that's both beautiful and terrifying. Reality might be watching us, just as we watch it. Are we living in a constructed reality? The simulation hypothesis. The deeper science dives into the nature of reality, the more it begins to resemble something eerily familiar, a simulation. What was once a fringe philosophical idea has now crept into mainstream science, discussed not only by speculative thinkers, but by physicists, computer scientists, and even technology billionaires. The unsettling question they're now daring to ask is this: what if our universe, everything we see, touch, and feel, is not the ultimate reality at all, but a kind of hyperreal simulation? It sounds like science fiction, yet as evidence accumulates from cosmology, quantum physics, and information theory, the simulation hypothesis is starting to look less like fantasy and more like a serious, testable theory about existence itself. The roots of the simulation hypothesis trace back centuries, long before computers existed. The ancient Greek philosopher Plato imagined humanity living in a cave, watching shadows on the wall and mistaking them for reality. Centuries later, René Descartes proposed that our senses could be deceived, that all of reality might be an illusion created by a clever trickster. But it was philosopher Nick Bostrom of Oxford University who, in 2003, turned this age-old doubt into a rigorous scientific argument. His paper, "Are You Living in a Computer Simulation?" didn't claim we are living in one. Instead, it made a mathematical point that if any civilization in the universe ever becomes technologically advanced enough to simulate conscious beings, then simulated realities will vastly outnumber real ones. In that case, statistically speaking, the odds that we are in the original base reality become almost zero. To put it simply, if simulated universes are possible, there would be countless copies, and we'd almost certainly be inside one. At first, this sounded like philosophy, but then physics began to catch up. When scientists looked closer at the universe, they found something strange. It behaves more like a computer than a clockwork machine. Everything we know, matter, energy, even space and time, can be described as information. The smallest unit of physical reality, the Planck length, is about 10 circumflex 35 meters. Nothing smaller can exist. Space isn't continuous. It's pixelated, like the pixels on your screen. Time too might tick forward in discrete intervals, frames in a cosmic video game. Physicist John Archibald Wheeler summarized this revelation in 3 words: it from bit. Reality, he said, arises from information, from binary yes-no decisions, the same fundamental logic that drives computer code. Even our universe's laws seem computational. Gravity, electromagnetism, and quantum forces can all be described as sets of mathematical rules operating on data. Every particle interaction could be viewed as an exchange of information. Every atom, a bit. Every physical law, an algorithm. If that sounds like how a simulation runs, that's because it is. So if we are living in a simulation, what might the code look like? And could we ever detect it? Some scientists believe we might already have. In 2012, researchers at the University of Bonn suggested that a simulated universe would leave detectable signatures, tiny glitches or constraints in high-energy cosmic rays. These particles, which travel near the speed of light, might not move perfectly smoothly if the universe were rendered on a discrete grid. The patterns of their arrival could reveal a cosmic resolution limit. The universe is equivalent of pixel density. Others have noted the eerie regularity of physical constants, numbers like the speed of light, Planck's constant, or the fine structure constant. which seem perfectly tuned for life. Change them even slightly and the universe collapses. Is that coincidence, or the result of a simulation's fine-tuning? Then there are the so-called quantum glitches, moments where particles seem to snap into place only when measured. It's as if the universe is running on-demand rendering, like a video game loading graphics only when a player enters a new area. The parallels are uncanny. Even energy itself behaves in quantized chunks, discrete packets called quanta. It's as though the universe conserves processing power, updating only what's necessary. But if we're in a simulation, who's running it? Bostrom offered 3 possibilities. 1. No civilization will ever reach the technology required to create conscious simulations. 2. Civilizations that do reach that level choose not to simulate reality. 3. Simulated realities already exist, and we're inside one. The third option, however unsettling, has become the most popular among modern thinkers. Elon Musk famously stated in 2016, "The odds that we are in base reality is 1 in billions." He argued that since our own video games have evolved from simple pixels to near photorealistic virtual worlds in just a few decades, imagine what a civilization millions of years ahead of us could do. They wouldn't just simulate visuals. They could simulate consciousness, emotion, even entire civilizations, each unaware they're digital constructs. And here's the twist. Those civilizations could, in turn, create their own simulations, creating an infinite nesting of realities. Somewhere up the chain, there might be a base reality. But from our point of view, we'd have no way of knowing whether we're the first or the billionth layer. If the universe is a simulation, then everything, stars, galaxies, even the laws of physics, exists because they're part of the program. But that doesn't mean it's meaningless. Quite the opposite. If our reality was designed, it might have purpose built into it, a narrative arc even. Our lives could be meaningful not in spite of being simulated, but because of it. Maybe we're characters in a story far greater than we can perceive, unfolding according to rules set long before we existed. That idea echoes ancient beliefs. Religious traditions around the world have described reality as a divine creation, a projection, a dream, a thought in the mind of God. The Bhagavad Gita calls the universe Maya, an illusion. Mystics throughout history have said the physical world is a shadow of something higher, a simulation of consciousness itself. Now, science is beginning to echo what mystics have whispered for millennia. That reality might be a manifestation of mind. Here's where things get even more mysterious. If we are simulated, how do we explain consciousness, our awareness of being aware? Even the most advanced computer simulations we've created, like artificial intelligence models or virtual avatars, don't truly feel. They process information, but they don't experience. So, if we are conscious, then whoever created this simulation didn't just build physics, they built perception. They programmed feeling, thought, memory, curiosity. That means consciousness itself might be the most fundamental element of the code, not an emergent property, but the very source of reality. Which brings us back full circle to quantum mechanics. The strange behavior of subatomic particles, the way they collapse into definite states only when observed, might be the universe's own feedback loop, a built-in mechanism connecting awareness to existence. In other words, the simulation isn't just running consciousness. Consciousness might be running the simulation. So, if reality is simulated, is there a way to escape it? Not in the Hollywood sense of unplugging from the matrix, but perhaps through understanding. If consciousness is the core of reality, then expanding awareness might be the key to accessing deeper layers of the code. Meditation, near-death experiences, and altered states have all been described by mystics as glimpses beyond the illusion, moments when the boundary between observer and creation dissolves. Maybe enlightenment isn't about leaving the simulation. It's about realizing you're part of the system that's creating it. That thought turns fear into wonder. If we're simulated beings, we're still real to ourselves. Our emotions, dreams, and choices matter. They're part of the story being told. And maybe, just maybe, our awareness helps evolve the simulation itself, pushing it towards something greater. In the end, whether the universe is physical or digital, designed or spontaneous, one truth remains. It behaves like something that knows it's being observed. Maybe reality is both, a living simulation, constantly rewriting itself in response to consciousness. Because the more we look, the more it looks back. At some point, every discussion about the universe, its origins, its design, its strange mathematical beauty, circles back to one question that refuses to die. What if consciousness didn't come from the universe, but the universe came from consciousness? Beyond the simulation. Consciousness as the architect of reality. It's an idea that sounds poetic, almost mystical, yet it's becoming impossible for science to ignore. The deeper we peer into the nature of reality, the more it behaves like something aware, something responsive, intelligent, and eerily connected to the act of observation itself. For decades we believed that consciousness was a byproduct of matter, that the brain, made of atoms and neurons, somehow produced awareness, like a factory spitting out thought. But that explanation is starting to fall apart. Because when we look closer, matter itself starts to dissolve. Take a grain of sand, zoom in close enough, and you'll find molecules. Zoom further, and you'll see atoms, tiny spheres orbiting a nucleus. But go even deeper, and the atoms aren't solid at all. The electrons aren't little balls spinning around a center. They're probability clouds, mathematical patterns of where they might be. In other words, matter, the solid stuff we build our world from, doesn't actually exist in any definite way until it's observed. This is the great paradox of quantum physics. Particles behave like waves of infinite possibilities, but the moment they're measured, they collapse into a single reality. Observation isn't just passive, it changes what's real. It's as if the universe is waiting for someone to look before deciding how to exist. The act of observing, or being aware, is woven into the fabric of existence. If that's true, then consciousness isn't just something happening in the universe. It might be the very thing holding the universe together. The physicist John Wheeler, who coined the phrase black hole, once proposed the participatory universe. His idea was simple but profound. Reality isn't a finished structure. It's a living process that requires observers. The universe, he said, doesn't exist independently. It exists because consciousness participates in it. Think about that for a second. Every moment of perception, every act of awareness, might be helping to generate the reality you experience. It's not that we're imagining the world, it's that consciousness and the universe are engaged in a constant dance, each shaping the other. This line between physics and philosophy is starting to blur. In ancient teachings from Hinduism, Buddhism, and Taoism, the universe has long been described as a projection of consciousness, not the other way around. The Sanskrit word Brahman refers to the infinite conscious essence from which all things arise. The Atman, or individual soul, is said to be a spark of that same consciousness, temporarily dreaming itself into form. Modern science, unknowingly, is echoing the same message, but through equations instead of poetry. Neuroscientists studying consciousness are finding that awareness cannot be fully explained by brain activity alone. The brain doesn't create consciousness, it filters and channels it, much like a radio tuning into a specific frequency. When the brain is damaged, consciousness may alter, but it doesn't vanish, suggesting that it exists beyond the physical structure that houses it. In countless experiments, from the classic double-slit experiment to modern quantum computing, researchers have found that the simple act of observation changes results. Particles behave differently when watched. Light shifts from a wave to a particle depending on whether someone is measuring it. But what counts as an observer? Is it a human? A camera? A conscious mind? Some physicists, like Eugene Wigner, took this further. Wigner argued that consciousness itself must be part of the equation, that without an aware observer, there's no collapse of possibilities into a single outcome. Reality, then, is not a fixed stage. It's a constantly updating field of potential that solidifies only through awareness. You are not inside the universe, he suggested. The universe is inside your awareness. Imagine for a moment that you're dreaming. Inside that dream, everything feels real. The ground beneath your feet, the sound of voices, the feeling of wind on your skin. But when you wake up, you realize it was all happening in your mind. Now, reverse the perspective. What if waking life isn't fundamentally different? Just another level of the same dream. Quantum physics hints that reality might function like a shared dream of consciousness, bound by consistent rules we call physical laws. These rules make the dream coherent, but they don't make it any less mental in nature. And if consciousness is primary, then death, distance, and time are not absolute boundaries. They're constructs of perception. The dream continues, even when one version of it ends. This view aligns with a growing scientific theory known as panpsychism, the idea that consciousness is a basic property of the universe, like space, energy, or gravity. Instead of being rare, consciousness is everywhere, embedded in every atom, every photon, every piece of existence. It's not that rocks think, but that the particles within them possess the faintest flicker of awareness, a trace of the same field that animates you. If so, consciousness doesn't arise from complexity. It's fundamental. Every mind, every star, every cell is part of one vast ocean of awareness expressing itself through different forms. We are not separate observers looking at a universe. We are the universe observing itself. Even black holes, once thought to be the ultimate dead ends, are starting to reveal strange, mind-like properties. Recent discoveries suggest that black holes encode information about everything they consume, storing it in subtle quantum vibrations along their event horizons. It's as if they remember what they've eaten, in a way that defies physical explanation. Physicist Leonard Susskind calls this holographic reality, the idea that the universe is a projection of information stored on its boundaries. That means everything we experience, all of space, all of matter, might be a three-dimensional shadow of data existing on a two-dimensional surface. And what processes that data? What translates it into the vivid, living world we experience? Consciousness. The mirror principle. If consciousness is indeed the architect, then life begins to make more sense. The synchronicities, the moments of intuition, the dreams that seem to predict, they're not coincidences. They're reflections. The universe could be a mirror, showing you the contents of your inner world projected onto an outer screen. Your beliefs, emotions, and intentions might literally influence reality. Not through magic, but through resonance with the conscious field that creates it. This would explain why quantum physics and spirituality have started to overlap. Manifestation, prayer, and focused thought all operate on the same principle, that consciousness shapes potential into form. You're not a powerless observer drifting through a meaningless cosmos. You are, in a very real sense, a co-creator of the reality you experience. If the 20th century belonged to physics, the 21st might belong to consciousness. More and more scientists are realizing that understanding awareness may be the key to solving the mysteries that equations alone cannot. Dark matter, dark energy, the origin of the universe, all might point not outward, but inward. Because if consciousness is the foundation of everything, then the search for truth begins not in telescopes or accelerators, but in the human mind. We may not be looking at the universe from the outside. We may be looking at ourselves from within the infinite. And if that's true, then the phrase, "very wrong with our universe," takes on a new meaning. Perhaps nothing is wrong at all. Perhaps the universe is just trying to wake us up, to remember what it really is, a dream of awareness, an infinite thought, a mirror made of light, the new science of the impossible. Science used to draw clean lines between what was possible and what was not. The impossible was superstition, the stuff of fantasy novels, spiritual visions, and late-night storytelling. Reality, we were told, followed strict rules. Equations dictated what could and couldn't happen. But those lines are blurring. Today, scientists are witnessing events that defy those rules, particles that appear to communicate faster than light, energy fluctuations that arise out of nothing, objects that seem to exist in two places at once. The impossible is not happening in some mystical realm. It's happening in laboratories, under controlled conditions, observed and verified. Something in our understanding of reality is broken, or perhaps something greater is breaking through. It began with one of the strangest experiments ever conceived, the quantum entanglement test. When two particles become entangled, their properties become linked, no matter how far apart they are. Change one, and the other instantly reflects that change. Einstein called it spooky action at a distance, because it violated everything he believed about the speed of light, that nothing, not even information, could travel faster. Yet experiment after experiment confirmed it. In 2015, teams around the world finally closed every possible loophole, proving entanglement was real. Two photons, separated by kilometers, were still connected, instantly, as if space itself didn't exist between them. This single observation shattered the foundation of classical physics. It suggested that the universe isn't a collection of separate parts interacting through space and time, but a single unified whole, a vast web of instantaneous connection. If the universe is a computer, entanglement is the code linking every bit of data. If the universe is conscious, entanglement is the language through which it speaks to itself. Then came the discoveries that made time, our most familiar dimension, look suspicious. In some quantum experiments, cause and effect don't happen in the expected order. A decision made now can appear to influence a result that happened in the past. Researchers call this retrocausality. It doesn't mean time travel in the Hollywood sense, but it means the future and past are not as separate as we think. Time might not flow in one direction at all. It may loop, bend, or exist all at once. At the quantum level, particles seem to exist outside time. They don't age. They don't move from point A to point B. They appear, disappear, and reappear, as if skipping frames in a film. Physicists are starting to ask whether time itself is a human illusion, a convenient way for consciousness to experience change in a reality that might be timeless by nature. Another impossibility emerged from the so-called vacuum of space. For centuries, nothingness was assumed to mean exactly that, emptiness. But when scientists looked closer, they discovered the vacuum isn't empty at all. Even in absolute void, tiny bursts of energy flicker into existence. These virtual particles appear and vanish in trillionths of a second, creating a constant background buzz known as the quantum foam. It's a seething ocean of potential from which reality seems to arise moment by moment. In one of the most haunting discoveries, scientists realized that the energy of empty space, this invisible foam, is enough to outweigh all visible matter in the universe. The unseen outweighs the seen by nearly 95%. That means everything we can touch, measure, or see is just a small ripple on the surface of something far deeper and more mysterious. Then there are the experiments that hint at motion faster than light, the one rule once thought untouchable. In 2011, physicists at CERN observed neutrinos apparently traveling faster than light. Though later attributed to a faulty cable, the very fact that such a result was possible set the world buzzing. Since then, evidence has emerged of superluminal tunneling, quantum particles appearing to skip barriers instantaneously without passing through them. In 2022, Chinese physicists observed particles of light, photons, that seemed to transfer information instantaneously without obeying normal time delay. If this holds true, then Einstein's cosmic speed limit is not absolute. It's local. Something beyond our visible space-time is allowing these instant connections to occur. That something might be the quantum field itself, a dimensionless sea beyond time and distance, where all points are connected. In other words, what we call faster than light might not be fast at all. It might be outside the concept of speed. Another unsettling revelation comes from the famous double-slit experiment, where light behaves as both a wave and a particle depending on whether it's being observed. When no one watches, light spreads out like a wave, forming patterns of probability. When observed, it collapses into particles, choosing specific paths. That means observation doesn't just reveal reality, it helps create it. To make things even stranger, scientists discovered that the act of observation can be delayed, and the outcome still changes retroactively. You can decide to measure a photon after it's already passed through the slits, and the photon somehow behaves as if it knew what you'd do. The universe appears to be aware of being watched. If consciousness and matter are entangled at the deepest level, then reality might be participatory, a co-creation between awareness and existence. In 2020, researchers conducted what they called the Wigner's Friend experiment, an updated test of observer effects. Two separate observers, measuring the same quantum event, recorded different realities. Both were correct, but their versions of reality could not be reconciled. That means at the quantum level, there might not be one objective universe, but many overlapping ones, depending on who observes them. If that's true, reality isn't singular. It's relational, shaped by perspective. The world you experience might be literally different from the one someone else occupies, though you share the same physical space. It's a conclusion that has forced physicists to flirt with what used to be philosophical heresy. The universe might be subjective. As strange as all this sounds, the impossible is already being harnessed. Quantum computers, which use the bizarre rules of superposition and entanglement, now perform calculations that would take classical machines billions of years. They don't just compute, they feel their way through infinite possibilities simultaneously, finding answers through patterns no human logic can trace. In quantum encryption, messages are encoded using entangled particles. If anyone tries to intercept them, the message destroys itself instantly. It's the first technology that's not just unhackable, it's physically protected by the nature of the universe itself. Science is no longer just describing reality, it's beginning to manipulate the rules beneath it. Strangely, as the scientific frontier pushes deeper into the impossible, it starts to echo the words of mystics, sages, and shamans who spoke of hidden dimensions, interconnectedness, and the illusion of separation. For centuries, mystics claimed all minds are connected, all things arise from one source, and the fabric of existence responds to intention and awareness. Physicists now describe a similar picture, a quantum field connecting all matter, where observation shapes outcome, and where information never dies. The language has changed, but the message feels hauntingly familiar. It's as though science and spirituality, long estranged, are meeting again at the edge of reality. Each impossible discovery forces us to ask a deeper question. What if the impossible is not a glitch, but a clue? Maybe these phenomena, entanglement, retrocausality, spontaneous creation, are the fingerprints of a deeper order, something beyond our current comprehension. The boundaries of the known world are not expanding outward. They're collapsing inward, revealing that the universe might not be an external machine, but an inner landscape of mind. If that's true, then the next revolution in science won't come from building bigger telescopes or colliders. It will come from understanding consciousness, the observer, the creative engine that makes reality real. Because maybe the impossible isn't breaking the laws of physics. Maybe it's revealing that those laws were never complete to begin with. Reality is beginning to behave like a dream we're just starting to wake up from. One where light bends around thought, time listens to will, and everything impossible is only waiting to be understood. The more science looks into the unknown, the clearer the pattern becomes. The impossible is not the enemy of truth. It's the invitation to see that truth was never limited by the possible at all. The holographic universe. Imagine this for a moment. Everything you've ever touched, every planet ever formed, every galaxy glittering in the distance, could be nothing more than a projection, not metaphorically, but literally. A three-dimensional illusion cast from information stored on a distant, invisible surface. It sounds like something out of a science fiction film, but this is a genuine hypothesis being taken seriously by many of the world's leading physicists. It's called the holographic principle, and it might be the most mind-bending idea in all of science. The seed of this strange theory was planted decades ago when physicists began studying black holes, those mysterious, light-swallowing monsters of space. According to the laws of physics, any information that falls into a black hole should be gone forever. But that posed a serious problem. In physics, information, the basic blueprint of particles and energy, can never truly be destroyed. So where did it go? In the 1970s, Jacob Bekenstein and Stephen Hawking discovered something astonishing. The amount of information a black hole can contain, its entropy, wasn't proportional to its volume, as most would expect. It was proportional to its surface area. Everything happening inside the black hole seemed to be encoded on its outer boundary, like data stored on a two-dimensional sheet. That realization was so radical that it began to shift how scientists thought about the universe itself. If information about everything that happens in a black hole is stored on its surface, then maybe the same is true for our entire universe. Maybe what we experience as three-dimensional reality, depth, space, distance, is actually a kind of projection from information encoded on a distant cosmic horizon. In other words, our universe might be a hologram. This isn't some fringe fantasy. In fact, the mathematics behind it are consistent with what we know about quantum mechanics and general relativity, two theories that normally refuse to get along. When physicists try to combine these two foundational frameworks, the smooth fabric of space-time from Einstein's theory and the jittery world of quantum particles, things fall apart. But the holographic principle seems to be the one place where they might peacefully coexist. Here's where things get even stranger. If our universe is holographic, it means that what we perceive as reality, every tree, every star, every heartbeat, might not be happening in real 3D space. Instead, it's information being played out, pixel by pixel, like a movie projected onto the screen of our perception. Reality, then, is not something we live in, but something that's being generated around us. Physicist Juan Maldacena, one of the pioneers of this idea, proposed a model that stunned the scientific world. He found that a theory describing gravity in a three-dimensional space could be perfectly equivalent to a theory without gravity in a two-dimensional space. The math checked out completely. It was as if two radically different realities were secretly describing the same universe, one with depth, one without. If this is true, it changes everything. It means that our sense of distance, our concept of space, might just be emergent, a useful illusion that helps us navigate a deeper reality made entirely of information. Think about it like this. A video game looks three-dimensional, but the game's code, the real data, exists on a flat chip inside a console. To the player, everything looks deep and solid, but behind the curtain, it's all ones and zeros. And that raises a haunting question. If the universe is a hologram, what is the chip that's generating it? Where does this information live? Some physicists believe that the edge of the universe, known as the cosmic horizon, could hold this data, a kind of vast, invisible boundary where all the information about everything inside our universe is encoded. Others suggest that the information is woven into the quantum fields themselves, existing everywhere at once. To ordinary experience, of course, none of this feels true. You touch your desk, you feel its hardness. You see the stars overhead, you sense the vastness of the night sky. Everything seems real and solid. But so did the Earth's flatness once upon a time, and humanity has a long history of mistaking appearance for truth. What makes this all the more unsettling is that experiments are starting to hint that something might indeed be off about space itself. In 2014, a group of scientists at Fermilab built a device called the holometer, essentially two ultra-sensitive laser interferometers designed to detect tiny vibrations in space-time. They were searching for signs that reality might be grainy, that space itself might be made of discrete bits of information rather than being perfectly smooth. The early results were inconclusive, but the effort itself revealed how seriously scientists are beginning to test the idea that the universe might not be as continuous or solid as it seems. And yet, if space and matter are illusions, if everything around us is a kind of projection, then what does that make us? Are we part of the hologram too? Are our thoughts, emotions, and choices just patterns encoded on the cosmic surface? Or could consciousness be something deeper, something that exists beyond the holographic layer, watching the movie unfold? That's where science and philosophy begin to merge in strange, almost spiritual ways. Some physicists argue that consciousness might be the decoder, the process through which this informational reality becomes the vivid world we experience. In that sense, reality could be participatory, not something that exists independently, but something that forms through observation itself. It's a dizzying thought. The universe might not be built from matter and energy, but from meaning and information, and consciousness could be the light that makes it all visible. The deeper scientists dig, the less the cosmos looks like a machine, and the more it feels like a story, one written not in atoms and forces, but in bits and awareness. The holographic principle doesn't give us all the answers, but it forces us to ask better questions, questions that cut to the heart of existence itself. What if the universe isn't a place we live in, but a process that's happening through us? What if, in the end, the entire cosmos is a grand illusion, and the only truly real thing is the act of perceiving it? The quantum fabric beneath matter. Take a deep breath and look around you. The table beneath your hands, the phone you're holding, the ground under your feet. All of it feels solid, real, unshakable, the foundation of existence itself. But here's the uncomfortable truth science has uncovered. None of it is truly solid. In fact, if you could zoom in far enough, you'd find that everything, including you, is made of almost nothing at all. At the smallest scales, matter dissolves into something so strange it defies human logic. What we call particles aren't tiny hard marbles of stuff. They're excitations, ripples, in invisible fields that fill all of space. The entire universe, from the most distant galaxy to the nerve cells in your brain, is nothing more than a storm of vibrations moving through these fields. This isn't just poetic language. It's the literal truth according to quantum field theory, the most accurate and successful framework in all of physics. It tells us that there are no true objects, only fields that stretch everywhere, overlapping, interacting, and constantly fluctuating. When you think of an electron, what you're really picturing is a tiny disturbance, a localized wave in the universal electron field. Every electron in the universe is just another ripple in that same field. Imagine the surface of a vast ocean. A wave rises here, another over there, distinct yet made of the same water. That's how matter works at the quantum level. You, me, the stars, all just temporary ripples in an endless sea of invisible energy. This idea shatters everything we once thought we knew about reality. The chair you sit on? 99.9999% empty space. The solidness you feel is just the electromagnetic forces between atoms repelling each other. There's no real contact, no solid touching solid. What you perceive as solidity is really a kind of resistance, like two magnetic fields pushing apart. In other words, the physical world we trust so deeply is a kind of illusion created by forces, not by matter. When scientists first began to explore this world beneath the atom, they were shaken. They expected to find smaller, simpler building blocks, the ultimate stuff of existence. But instead, they discovered something almost mystical. a fabric that behaves more like an ocean of potential than a pile of objects. Quantum fields aren't made of anything else. They are the base layer of reality. Even stranger, these fields never sit still. Even in absolute vacuum, where there should be nothing, they continue to fluctuate with wild energy. This restless dance of existence is what scientists call quantum foam, the roiling, flickering undercurrent that constantly births and destroys particles out of empty space. Reality, it seems, isn't made of permanence, but of perpetual motion. You might wonder how something so chaotic can give rise to something so orderly, a world of stars, trees, and human beings. The answer lies in the patterns that emerge from these underlying fields. Just like waves on the ocean can form repeating rhythms, the vibrations in quantum fields can synchronize and create what we perceive as stable matter. What we call reality might be nothing more than organized vibration, a grand symphony of quantum harmonies. Here's where things get almost metaphysical. If everything is vibration, if every particle is just a note in the cosmic song, then reality itself could be described as music made visible. Each atom in your body resonates with a frequency. The stars above, the cells within you, the space between, all of it is humming with invisible energy. The ancient philosophers who once said all is vibration were, in a strange way, right all along. But for physicists, this truth is both beautiful and terrifying. Because the more we study these fields, the more they seem to behave like information systems rather than physical substances. What we once thought were things are actually data points in a grand dynamic network, reality as a quantum information field. Some researchers now believe that information might be even more fundamental than energy or matter. It's not just that fields carry information. Information might be what fields are. Every particle interaction, every quantum fluctuation could be a tiny computation, the universe processing itself. That means physics and computing might not be separate ideas at all, but reflections of the same cosmic process. If this sounds abstract, consider how it echoes through your everyday life. The light hitting your eyes, the sound reaching your ears. These are vibrations in electromagnetic and air pressure fields. Your brain then decodes these vibrations into images, colors, and sounds. In other words, you are constantly interacting with the quantum fabric, translating waves into experiences. You don't just live in the field, you're made of it and shaped by it every second. And the deeper scientists go, the weirder it gets. In quantum experiments, particles can disappear from one point and reappear somewhere else without crossing the space in between. A phenomenon known as quantum tunneling. Others seem to communicate instantaneously across vast distances, defying the limits of speed, the mysterious behavior called entanglement. These effects suggest that what we see as separate parts of reality might be deeply interconnected beneath the surface, stitched together by an invisible unity we can't yet comprehend. This leads to one of the most haunting ideas in modern science. Maybe space itself isn't truly separate. Maybe the distance between things isn't real, but a kind of mirage created by how the quantum fields interact. The universe might not be spread out like a vast stage, but rather folded together, like different points on the same sheet of paper touching in unseen ways. If that's true, then the borders between me and everything else begin to blur. The atoms in your body were forged in the heart of long-dead stars, their particles indistinguishable from those in the air you breathe. You are not apart from the cosmos. You are the cosmos, momentarily aware of itself. Physicist John Wheeler once suggested that reality might best be described by the phrase "it from bit," meaning every it, every particle, star or galaxy emerges from bits of information. Reality, at its deepest level, could be digital, not material. But unlike computer code, this cosmic code isn't stored on a chip. It's stored in the very structure of space-time. So when you look at your hand, you're not seeing matter. You're seeing waves of energy organized by invisible patterns of information. When you speak, when you think, when you dream, you're generating ripples through this same quantum ocean. The universe, then, isn't just out there. It's within you, humming, vibrating, alive. And maybe that's the most profound discovery of all, the realization that everything, every mountain, every heartbeat, every flicker of light, is part of one vast living field. A universe that isn't a collection of separate things, but one continuous whole. Beneath all the noise and complexity, everything we know might just be one endless vibration, the quiet song of existence itself. When reality becomes information, imagine waking up one morning and realizing that the world around you, the colors, the air, the sound of traffic outside, isn't made of matter at all. It's data. Pure information flowing through a vast network that we call the universe. Not metaphorically, literally. This is not a sci-fi dream anymore. It's where the deepest frontiers of physics and cosmology are now pointing us. The more scientists study the structure of the universe, the more it looks like a system that processes information rather than one that simply exists as physical stuff. Every atom, every light wave, every quantum interaction may be nothing more than information being exchanged in an unimaginably large cosmic computation. It sounds wild. But think about what we already know. At the heart of quantum physics is the fact that particles don't really exist in a specific place until they are measured. Until that moment, they exist as a wave of probabilities, a collection of potential outcomes. Only when observation or interaction happens does the universe choose one result. It's as if reality doesn't commit to existing until the information is read. That single idea flipped the world of science upside down, because if reality waits for information exchange before solidifying, it implies that the universe operates on rules that look a lot like computation. Input, processing, output. The physical world, then, might not be the foundation of existence. It might be the result of something deeper, the flow and transformation of information. This isn't abstract philosophy, it's grounded in real physics. Every quantum state carries information. The laws of thermodynamics, once about heat and energy, are now being rewritten in terms of information flow. Even black holes, once considered ultimate destroyers, are now seen as information vaults, storing the data of everything they consume on their event horizons. Stephen Hawking's discovery that black holes slowly evaporate over time created a huge paradox. If black holes disappear, where does the information about what fell in go? Quantum mechanics says information can't be destroyed. That contradiction nearly broke modern physics. But the resolution, astonishingly, suggested that the information is never lost. It's encoded in subtle patterns spread across the surface of space-time itself. That was the light bulb moment. If black holes can store reality as information on their surfaces, maybe the entire universe works the same way. Maybe the cosmos isn't made of matter expanding through space. It's made of data unfolding across an invisible informational field. In this view, everything that exists is the outcome of a continuous computation running on the hardware of space-time. Galaxies form because of coded rules. Electrons spin because the universal algorithm says so. Even consciousness could be part of the same program, a self-aware output of the information network observing itself. That last part is what truly bends the mind. Because if consciousness and reality are both forms of information, then maybe they're not separate at all. Maybe they're two sides of the same coin, the observer and the observed, both emerging from the same fundamental process. Some physicists are now exploring this idea through the field of quantum information theory, where the universe is treated less like a machine and more like a vast computation. Every interaction between particles becomes a transfer of bits. The entire fabric of space-time becomes an information web. To put it simply, the universe behaves like the ultimate quantum computer, one so vast and complex that everything within it, including us, is part of its code. But what's truly fascinating is how this new understanding reshapes our sense of real. When you walk through a forest, you see trees, feel the breeze, smell the earth. It feels concrete and undeniable. But what's really happening is an astonishing symphony of information processing. Photons carrying visual data strike your retinas. Electrical impulses transmit that information to your brain, and your consciousness decodes the signals into color, texture, and shape. You're not directly perceiving the world, you're reading it, interpreting patterns of information that have been translated through your senses. Reality, to each of us, is not a direct experience, but an interpreted one. Now, zoom out to the cosmic level. Physicists studying quantum fields, gravitational waves, and dark energy are realizing that the same principle may apply to the entire universe. What we perceive as space, time, and matter could be just different expressions of the same fundamental language, information. Some even propose that space-time itself might emerge from information. In their models, bits of quantum data form networks called spin networks, or quantum graphs, mathematical structures that weave together to create what we experience as space. Time, in this framework, isn't something that flows. It's something that updates, moment by moment, like frames in a film reel. If this is true, then what we call reality might not be a thing that exists independently at all. It's an ongoing computation, constantly rewriting itself, constantly producing the next frame of the universe. And just like a computer program, it can glitch. The strange anomalies scientists keep finding, the Hubble tension, quantum inconsistencies, the weird behavior of particles, could be signs that we're seeing the limits of this informational fabric. As if the universe's code isn't perfectly smooth, as if something deep beneath the surface is slightly out of sync. It's a haunting thought. Maybe what we call the laws of physics aren't timeless truths. Maybe they're just rules of the system, parameters that could change under the right conditions. That means, theoretically, our universe could be one of countless informational realities, each with its own code, its own physics, its own logic. The multiverse, in this sense, wouldn't be made of separate physical realms, but of different informational blueprints running parallel to each other, like multiple programs running on the same cosmic processor. And where does that leave us? It leaves us at a crossroad between science and something deeper, between cold equations and profound wonder. If reality is information, then consciousness, the thing reading and interpreting that information, might be the only truly real element in the entire story. You could think of existence as a two-way dance, the universe computing itself into being, and consciousness experiencing the result. Each observation, each act of awareness, adds another line to the cosmic script. The more we look, the more reality seems to depend on being looked at. It's no wonder that physicists like Wheeler concluded that the universe is participatory, that we're not passive observers, but active participants in creating the reality we experience. So maybe the question isn't, what is the universe made of? Maybe it's, who is doing the observing? And if reality itself is information, if the universe is a kind of grand conscious computation, then perhaps, in some deep and mysterious way, we are the universe remembering itself. Each thought, each heartbeat, each question we ask adds another pulse to the rhythm of creation. Because maybe, in the end, information isn't just what the universe is made of, it's what it means to exist at all, the collapse of objectivity. There was a time when science seemed certain about one thing. Reality existed whether anyone was looking or not. The moon would still hang in the sky, the stars would still burn, and the atoms in a rock would still spin, no matter if a human eye ever noticed them. That assumption, objectivity, was the bedrock of modern science. It's what gave us confidence that we could study the universe as something separate from ourselves. But then came quantum physics, and with it, a quiet earthquake that shattered the very idea of an independent reality. The revolution began in the early 20th century, when physicists began probing the smallest building blocks of nature. They expected to find little marbles, tiny, solid particles that obeyed predictable rules. But what they found instead was far stranger. The deeper they looked, the more reality seemed to slip through their fingers. At the quantum level, particles behaved in ways that defied logic. Sometimes they acted like solid points, other times like waves spread across space. They could exist in multiple places at once, travel through barriers, and even seem to affect each other instantly across vast distances. None of it made sense. To make matters worse, everything depended on observation. In experiment after experiment, scientists found that a particle's state wasn't fixed until it was measured. Until that moment, it existed in a kind of ghostly superposition, many possible realities overlapping. But once it was observed, all those possibilities vanished, leaving behind a single outcome. It was as if the universe itself waited for someone, or something, to look before deciding what to be. Imagine firing tiny particles, like electrons, through two narrow slits onto a screen. If you don't observe them as they pass through, they behave like waves, interfering with each other and forming a pattern of light and dark bands. But the moment you try to detect which slit each particle goes through, just by observing, it stops behaving like a wave and acts like a solid particle instead. The interference pattern disappears. The act of looking changes the result. Think about that for a moment. The universe behaves one way when unobserved and another way when watched. It's not just poetic, it's empirical. No matter how scientists have tested it, the results stay the same. The observer is built into the physics itself. This was deeply unsettling. The founders of quantum mechanics couldn't agree on what it meant. Niels Bohr argued that observation was fundamental, that we could never separate the act of measurement from the thing being measured. Later experiments have only deepened the mystery. In the 1970s, physicists performed what's known as the delayed choice experiment, designed by John Wheeler. In this setup, a photon travels through an apparatus where scientists decide, after the photon has already passed through, whether to measure it as a wave or as a particle. Unbelievably, the photon seems to know what decision will be made in the future and behaves accordingly. It's as if cause and effect themselves break down. The observation doesn't just reveal what happened, it defines what happened even retroactively. So what's going on? Is the universe conscious of being watched? Does it somehow adapt to our attention? Many physicists are careful not to use mystical language, but it's hard to ignore the implications. If observation changes reality, and if observation requires awareness, then awareness itself might not be something separate from the universe. It might be an active ingredient in its formation. This leads to a radical possibility. Objectivity might be an illusion. There might be no reality out there that exists independently of the act of perception. The universe and consciousness might be two parts of the same loop, each giving rise to the other in an endless dance. That idea used to sound absurd. But in recent decades, it's gained quiet traction across physics, neuroscience, and even philosophy. Thinkers like physicist John von Neumann and mathematician Eugene Wigner propose that consciousness causes collapse, that it's the mind, not the measuring device, that crystallizes the fuzzy world of probabilities into something real. More recently, physicist Carlo Rovelli introduced an idea called relational quantum mechanics. In his view, there is no single objective reality at all. Reality is made of relationships, interactions between systems. What's real for one observer might not be real for another, and both can be correct. There is no view from nowhere. The universe, at its core, is a web of perspectives, not a stage filled with things. This turns everything upside down. Science, which once prided itself on standing outside the world and describing it objectively, now faces a truth that sounds almost spiritual. There is no outside. There is only participation. When you look at a star, you're not just seeing light that's traveled for millions of years. You're completing the act of its existence in your awareness. When you measure an atom, you're not just revealing its position. You're defining what position even means. In this sense, consciousness becomes the bridge between potential and reality. Before observation, the universe is a sea of probabilities, waves of possibility, humming quietly in the void. After observation, it's a world, specific, defined, alive. Without awareness, there's no collapse, no definition, no is. The implications are staggering. If reality requires participation, then every act of perception contributes to the construction of the universe. Every eye that sees, every mind that notices, every moment of awareness adds another thread to the tapestry of existence. And this doesn't just apply to humans. In quantum physics, any interaction that transfers information counts as an observation. When particles collide, when photons reflect, when atoms vibrate, they're all exchanging information, all participating in the act of creation. In that sense, the entire universe is self-observing. It doesn't need a separate witness. It witnesses itself. That could explain why the universe seems fine-tuned for life and consciousness in the first place. Perhaps awareness wasn't an accident that emerged from matter. Perhaps matter is what happens when awareness looks at itself. It's a dizzying thought. Reality may not be a cold mechanical machine running on blind laws, but a living network of relationships where meaning and measurement are inseparable. The cosmos may not be something happening to us. It might be something happening through us. When we gaze at the stars, the universe is, in a sense, looking back. If that sounds poetic, it's because it is. The deeper science goes, the more it begins to sound like ancient wisdom spoken in a new language. What mystics once called oneness, physics now calls entanglement. What philosophers called being, scientists now describe as the collapse of the wave function. And the message hidden in all of it might be this: the wall between observer and observed was never real. There was never a cold, detached universe waiting to be understood. There was only one great, interconnected whole, reality and consciousness, woven together, collapsing into existence in the same breath. So, perhaps the question isn't what happens when we observe the universe, but what happens to the universe when it observes itself through us. The universe that shouldn't exist, it's one thing for science to find surprises. It's another for those surprises to make us question whether the entire universe is wrong. Yet that's exactly where modern physics stands. The deeper scientists look, the more the cosmos seems to break its own rules. It's as if reality itself is glitching, a vast cosmic contradiction playing out on every scale. For centuries, humans have assumed the universe was stable, logical, and consistent. We built telescopes, colliders, and theories based on that assumption. The idea was simple. If we observe enough, measure enough, and calculate precisely, the truth will reveal itself. But lately, the truth has become stranger than anyone expected. Let's start with something familiar: galaxies. They are supposed to be held together by gravity, the same invisible force that keeps your feet on the ground. Yet when scientists measured the way stars move inside galaxies, the numbers didn't add up. The stars were moving far too fast, fast enough to fly apart into space. By all logic, most galaxies shouldn't exist. They should have torn themselves apart billions of years ago. To explain this, scientists propose something bold: dark matter, an invisible substance that doesn't emit or reflect light, yet provides the missing gravity to hold galaxies together. It was an elegant fix. The problem was no one could find it. Decades passed. Detectors were built deep underground and telescopes scanned the heavens, yet nothing showed up. No particles, no traces, no direct evidence at all. Still, the theory stuck. It had to. Without dark matter, the universe as we know it collapses. Galaxies, stars, even the cosmic web that connects them. All of it depends on something unseen keeping the universe in shape. But what happens when the unseen never appears? Then there's dark energy, another invisible force, this time pushing the universe apart. While dark matter holds things together, dark energy does the opposite. It accelerates the expansion of space itself, stretching galaxies farther and farther away from each other. Together, dark matter and dark energy are said to make up 95% of the universe. That means everything we can actually see, stars, planets, you, me, makes up only 5%. Think about that. According to science, almost everything in existence is invisible and unexplained. But here's where things get even stranger. When scientists try to measure the universe's expansion, they get conflicting results, wildly conflicting ones. The Hubble constant, the number that describes how fast the universe is expanding, depends on how you measure it. Looking at nearby galaxies gives one value. Studying ancient light from the early universe gives another. The difference between them isn't small, it's massive, and it refuses to go away. This isn't just a measurement error. Scientists have checked, recalculated, and built new instruments. The tension remains. It's as if the early universe was playing by one set of rules and the present universe by another. That's not supposed to happen. Time, space, and physics are supposed to be consistent, yet they're not. The deeper researchers dig, the more this inconsistency spreads. Cosmic microwave background radiation, the leftover light from the Big Bang, should be perfectly even, but it's not. Tiny temperature variations form a pattern that no one can fully explain. The universe also appears too smooth, too aligned in places, like a structure that was carefully arranged rather than randomly formed. Some scientists even whisper about the axis of evil, a mysterious alignment of cosmic features that shouldn't exist in a chaotic natural universe. And those are just the big mysteries. On the quantum scale, things get even more bizarre. Particles blink in and out of existence. They can be in two places at once, or entangled across galaxies, acting as if space doesn't separate them at all. It's as if reality doesn't follow the rules of distance or time. Some physicists believe that, deep down, the universe isn't made of matter at all, but of information. If that's true, then everything, from galaxies to human thoughts, might be part of a massive informational structure, like a cosmic code. The laws of physics wouldn't be laws of matter, but rules of computation. The universe, in this view, isn't a machine. It's a simulation. That idea sounds wild, almost philosophical, but every year, new discoveries make it harder to dismiss. Quantum computers can now simulate particles so accurately that their behavior becomes indistinguishable from real ones. The line between real and simulated is blurring. If we can simulate a universe, what's stopping a larger intelligence, natural or otherwise, from simulating ours? It's an unsettling thought, but it also fits too well. It explains why physical constants appear fine-tuned, why gravity, electromagnetism, and the properties of atoms seem perfectly adjusted to allow life. Change any one of them by a hair, and everything falls apart. That precision feels less like random luck and more like design. But design by what or whom? That's where science hesitates, because to even ask that question is to step beyond physics and into philosophy, even theology. Yet the clues keep pointing that way. The universe looks less like a cold mechanical structure and more like a living system, one that adapts, calculates, and perhaps even learns. If that sounds hard to believe, imagine this. The constants of nature might not be constant. Some evidence suggests they have changed slightly over billions of years. If true, it means the universe isn't fixed. It's evolving, rewriting its own rules as it goes. That would mean the laws of physics are more like temporary agreements in a larger process we don't yet understand. And this brings us to the strangest truth of all, the possibility that the universe shouldn't exist at all. When physicists model the conditions after the Big Bang, matter and antimatter should have been created in equal amounts. But if that were true, they'd have instantly destroyed each other, leaving behind nothing but light. Yet somehow, a tiny imbalance, 1 in a billion, allowed matter to win, creating stars, planets, and life. Why that imbalance existed is still a mystery. It wasn't predicted by any theory. It's as if the universe bent its own rules to allow itself to exist. So here we are, in a cosmos that defies logic, built from invisible matter we can't find, governed by forces we don't understand, and held together by rules that might not be permanent. It's no wonder scientists are uneasy. Every time they solve one mystery, another, deeper one appears beneath it. And somewhere in that growing uncertainty lies a quiet, terrifying possibility that the universe we live in isn't the real one. Or worse, that real might not mean what we think it does. The great cosmic mismatch. If there's one thing science prides itself on, it's consistency. For centuries, that was the golden rule. Measure, test, and the universe will always give you the same answer. But what happens when it doesn't? What happens when the sky itself starts to contradict your most trusted equations? That's where we are now, caught in the middle of what some scientists are calling the great cosmic mismatch. On paper, the universe is supposed to be simple. The standard model of cosmology, the one taught in universities, printed in textbooks and written in stone for decades, describes everything neatly. There's dark matter to explain gravity that can't be seen, dark energy to explain why the universe is expanding faster. Add in a sprinkle of ordinary matter, radiation, and the laws of physics, and it should all work perfectly. Except it doesn't. Everywhere we look, the universe seems to be breaking its own rules. The galaxies aren't behaving the way models predict. Stars are forming faster than they should. Black holes are appearing too early, too massive, too perfect. It's as if the cosmos we observe doesn't match the one science describes, like reading the wrong script to a play that's already happening. Take galaxies, for instance. According to the standard model, they should form gradually, tiny clumps of matter merging over billions of years. But telescopes like the James Webb Space Telescope have shattered that belief. What they're seeing is impossible. Peering deep into time, Webb has found massive mature galaxies that existed just a few 100 million years after the Big Bang. Galaxies so big and organized they shouldn't exist yet. It's like walking into a nursery and finding fully grown adults where newborns should be. The data stunned everyone. For years, scientists thought early space was chaotic, a place where gravity was still gathering the ingredients for galaxies. But these ancient cosmic structures looked calm, bright, and fully formed. Some even contain heavy elements that should have taken billions of years to produce. The implication is terrifyingly simple. Our understanding of how the universe grew up might be completely wrong. But that's just the start of the mismatch. When scientists chart the structure of the cosmos, the way galaxies cluster and form filaments across space, they find an eerie pattern. Instead of random distribution, there's symmetry, rhythm, and sometimes even alignment. Certain galaxy clusters line up along invisible cosmic axes that stretch for billions of light years. It shouldn't happen. The laws of physics predict a uniform random universe. But we keep finding direction and order where there should be chaos. Some researchers have quietly nicknamed it the cosmic fingerprint, a pattern so vast it defies explanation. And it's not only galaxies. Even the oldest light in existence, the cosmic microwave background, carries traces of alignment. It's supposed to be a perfectly even afterglow from the Big Bang. Yet strangely, it leans ever so slightly in one direction. This mysterious orientation has been called the axis of evil. It's as if the universe has a preferred direction, a cosmic north, when physics insists it shouldn't. This single anomaly shakes the foundation of cosmology. Because if the universe does have a preferred direction, it means something caused it, something outside the standard model, maybe even outside space-time itself. But the mismatches don't stop there. When astronomers try to calculate how much matter the universe contains, they get conflicting answers. The early universe seems to contain a different balance of matter and energy than the present-day one. That shouldn't be possible. Energy doesn't just disappear or multiply on its own. It's as if the universe keeps rewriting its own history, changing its numbers each time we look. Even time itself might not be behaving properly. In distant galaxies, light seems to stretch and fade in ways that don't align with standard expansion models. Some theories now suggest that the flow of time could vary depending on where you are in the universe, slower in some regions, faster in others. If that's true, it would mean there's no single universal clock. Every galaxy could be living in its own version of time. And if time isn't consistent, then nothing truly is. But what's perhaps most alarming isn't that these mismatches exist, it's how many of them are piling up. A decade ago, they were dismissed as measurement errors. A few years later, as statistical noise. Now, there are too many to ignore. The pattern is unmistakable. Something about our picture of the universe is deeply flawed. Some physicists suggest that dark energy, the mysterious force driving cosmic expansion, might not be constant. It could be evolving, changing over time, growing stronger or weaker. If that's true, then the universe might not expand forever. It could eventually slow down, collapse, or do something no one can yet predict. Others think the problem lies in gravity itself. Perhaps Einstein's theory, the most successful framework in history, isn't the full story. There might be hidden dimensions, unseen fields, or entirely new kinds of physics influencing reality. Still others believe the entire cosmological model, the one built around the Big Bang, might be incomplete. Maybe the universe didn't begin in a single explosive event, but cycles endlessly, expanding and contracting like a heartbeat. Whichever explanation turns out to be true, one thing is clear. The cosmos we observe doesn't fit the equations we worship, and the cracks are widening. Each new telescope, each new experiment, brings more data and more contradictions. It's as if the universe is laughing at us, daring us to understand it. We once thought we were close to having all the answers. Now every discovery only leads to deeper questions. And that's the great cosmic mismatch. Not just a disagreement between data and theory, but between what we think reality is and what it might actually be. Because if these observations are correct, then the universe isn't a smooth, predictable machine at all. It's something wilder, something alive with unpredictability. It may not follow laws, it may create them as it goes. That realization changes everything. It means space and time aren't fixed. It means constants might not be constant. It means the universe we live in today isn't the same one that existed yesterday. For the first time in history, science isn't mapping the universe, it's chasing it. And with every discovery, the truth grows stranger. The cosmos we thought we understood has slipped through our fingers, leaving behind only patterns, contradictions, and whispers of something far beyond our comprehension. Something that's trying to tell us that maybe, just maybe, we've been reading the wrong version of reality all along. The universe rewrites itself. At first, scientists thought the universe was static, an unchanging stage where stars burned, planets turned, and time marched steadily forward. Then they discovered it was expanding. That alone changed everything. Suddenly, space wasn't just a backdrop. It was alive, stretching, growing, and evolving. But now, as more evidence unfolds, it seems that even this might not be the whole story. The universe, it turns out, might be doing something far more mysterious, rewriting itself. This idea sounds almost poetic, but it's rooted in hard, uncomfortable data. Across the cosmos, physical constants, numbers that should never ever change, appear to be shifting. These are the bedrock of reality: the speed of light, the strength of gravity, the charge of the electron. If even one of them varied by the tiniest amount, everything would fall apart. Stars wouldn't burn, atoms wouldn't form. Life, as we know it, couldn't exist. And yet, there are hints that these constants aren't so constant after all. Over the past few decades, astronomers have studied the light from distant quasars, ancient, brilliant objects at the edges of the universe. As that light passes through space, it interacts with atoms and fields, leaving behind subtle fingerprints. By studying those fingerprints, scientists can measure how certain physical constants behaved billions of years ago. The results are shocking. Some measurements suggest that the fine structure constant, a number describing how light and matter interact, might have been slightly different in the distant past. Not much, just a fraction of a percent. But in the universe, even a fraction is everything. If that variation is real, it means the laws of physics have changed over time. The universe hasn't just expanded, it's evolved. It's like reality itself is learning, adjusting, or recalibrating as it goes. This is more than a scientific problem, it's an existential one, because if the rules of nature can shift, then nothing about our universe is fixed. Not its past, not its future, not even its meaning. Some scientists have started to see the universe less as a static system and more as a living process, one that adapts and redefines its own structure. The laws of physics might not be timeless truths, but temporary rules that apply only in certain eras or conditions. That sounds impossible, but so did almost everything we've discovered about the cosmos so far. Consider dark energy, the mysterious force that's accelerating the universe's expansion. For years, physicists assumed it was constant, like a gentle push that never changes. But new data suggest otherwise. Observations of distant galaxies indicate that dark energy's strength may be shifting. In some regions, the acceleration seems to slow. In others, it speeds up. If true, it means dark energy could be dynamic, waxing and waning, responding to something deeper. Imagine if space itself could breathe, expanding and contracting, stretching and relaxing, like the rhythm of a vast cosmic heartbeat. That's what some models now propose. Instead of a one-time event like the Big Bang, the universe might go through endless cycles, expanding, collapsing, and being reborn in a grand cosmic loop. This oscillating universe theory isn't new, but it's gaining new weight. And if it's right, then what we call the beginning, the Big Bang, may have just been one of many. The universe might have existed before, countless times rewriting its own history over and over again. Even time may not be what we think it is. Most people imagine time as a straight line, past, present, future. But evidence from quantum physics and cosmology hints at something stranger. Time might be flexible, like a fabric that can fold, stretch, or even loop back on itself. Some experiments suggest that cause and effect, the foundation of reality, might not always move in one direction. That means the universe could be influencing its own past, rewriting history as it evolves. This sounds like science fiction, but the math keeps pointing there. In quantum mechanics, particles behave as if they already know what will happen, as if the future can reach back and shape the present. Some scientists believe the universe itself might operate the same way, a self-correcting system, constantly editing itself to maintain balance. So maybe the reason the cosmos seems so fine-tuned, so perfect for life, isn't luck or design. Maybe it's adaptation. Maybe the universe adjusts its own parameters to allow structure, complexity, and life to exist. That would mean the universe isn't a cold, mechanical void. It's more like an intelligent organism, one that evolves, learns, and perfects itself over billions of years. It's a breathtaking idea, but it also changes how we think about existence. Because if the universe can rewrite its own rules, then the reality we live in might be temporary, a draft, a version among many. Even cosmological constants, those sacred numbers we once believed eternal, might be negotiable. Perhaps gravity wasn't always this weak, or light always this fast. Maybe in another version of the universe, stars burned brighter, matter clumped faster, or life formed differently. And if reality can rewrite itself, who's to say it hasn't already, countless times, right under our noses? Quantum physics offers another clue. In experiments, the act of observation seems to affect reality itself. Particles behave differently when they're watched. This bizarre fact has led to one of the most profound questions in all of science. Does the universe need observers, like us, to exist the way it does? If it does, then consciousness isn't just a product of the universe, it's a participant in it. That would mean reality and perception are intertwined, constantly shaping each other. The universe writes its story, and we, by observing it, help write it back. Every discovery, every experiment, every act of looking changes the cosmic script a little more. Perhaps that's the real meaning of these anomalies. The Hubble tension, dark matter, shifting constants, and inexplicable alignments. Maybe they're not mistakes. Maybe they're traces of the universe rewriting itself. Moments where the edges of reality didn't quite line up during the edit. Science has always assumed that if we look deep enough, we'll find one final equation that explains it all. But what if there isn't one? What if the theory of everything keeps changing because the universe keeps changing? In that case, the search for absolute truth might be impossible, not because we're incapable of finding it, but because it doesn't exist, not permanently. Reality, it seems, is not a fixed code, but a living document, a cosmic script written, erased, and rewritten across time, and we're part of it. Every atom in our bodies, every thought in our minds, every action we take, all of it contributes to this ongoing revision. The universe isn't just happening around us, it's happening through us, reshaping itself one moment at a time. Maybe that's the ultimate secret science is slowly uncovering, that the universe doesn't need to make perfect sense because it's still making itself. The story of existence isn't finished. It's being written right now, in real time, by a cosmos that refuses to stay still. When reality stops behaving. For most of human history, we believed the world was predictable. Drop a stone, it falls. Strike a match, it burns. Every action had a clear cause and effect. It was comforting. A universe that followed rules, where logic was law. But then came quantum physics, and suddenly, reality stopped behaving. The strange thing about the quantum world isn't just that it's weird, it's that it shouldn't exist the way it does. It breaks the very logic that science was built on. And yet, it's the foundation of everything. Every atom, every molecule, every cell in your body. Beneath the calm surface of existence, the rules fall apart completely. Here's where the nightmare for physicists begins. When they look at the universe on a small enough scale, the laws of nature dissolve into chaos. Particles appear and disappear like ghosts. They can exist in multiple places at once, pass through barriers that should be solid, and even influence each other across unimaginable distances. Instantly, without any signal connecting them. Einstein himself called this spooky action at a distance. He hated it. It violated everything he believed about how the universe should work. But it was real. And every experiment since has confirmed it. The universe is stranger than even Einstein could accept. If you shoot particles, like electrons, through two narrow slits onto a screen, you'd expect them to form two stripes, right? After all, each particle should go through one slit or the other. That's logic. But instead, the pattern that appears isn't two stripes. It's a complex wave pattern, as if each particle went through both slits at once and interfered with itself. The truly mind-bending part, the moment you observe which slit the particle goes through, the interference pattern disappears. The act of watching changes the outcome. Reality itself rearranges depending on whether or not it's being observed. This experiment has been repeated countless times with different setups, photons, electrons, even entire molecules, and the result is always the same. When unobserved, matter behaves like waves, existing in multiple possibilities. When observed, those possibilities collapse into one. In other words, the universe doesn't decide what's real until someone's watching. Think about that. It's not just philosophical, it's experimental. Something about measurement, attention, or observation causes the quantum world to choose an outcome. Before that choice, everything exists in a blurry, undefined cloud of probabilities. This raises an impossible question. Does consciousness play a role in reality itself? It's one of the most controversial ideas in modern science, and one that refuses to die. Some physicists dismiss it, claiming that observation doesn't require a mind, just an interaction. But others aren't so sure, because if measurement alone were the answer, why does the universe behave as if it's aware of being watched? It's as if the cosmos itself has a built-in awareness, a kind of self-perception woven into its fabric. Things get even weirder with quantum entanglement. When two particles interact, they can become linked in such a way that their properties remain connected, no matter how far apart they move. Measure one, and you instantly know the other, even if it's on the opposite side of the universe. This isn't just a coincidence or a delayed signal. The change happens faster than light can travel. That shouldn't be possible. It breaks Einstein's speed limit. It breaks causality. It breaks everything. Some scientists think entanglement might be a hint of something deeper, a hidden layer of reality that connects everything, everywhere, all at once. Space might not be as empty as it seems. It might be a web, a vast, invisible network binding every particle, every atom, every thought. If that's true, then separation is an illusion. You're not isolated from the universe. You are the universe, entangled with every star, every galaxy, every point in space-time. That realization is both thrilling and terrifying. Because if everything is connected, then maybe the boundaries between mind and matter, observer and observed, aren't as clear as we think. Even time behaves strangely in the quantum world. In some experiments, particles seem to know the future, changing their behavior based on measurements that haven't even happened yet. It's as though cause and effect get tangled and time runs both ways. Physicists call this retrocausality, the idea that the future can influence the past. It defies every instinct we have about how reality should work. But experiments hint that it's real. Imagine tossing a coin and getting heads. But later, when someone decides to check, the coin flips itself to match that future observation. That's how the quantum world seems to behave. It's not linear. It's interactive, fluid, and aware. Some researchers now believe that quantum mechanics isn't just a description of small things, it's the underlying truth of everything. Our everyday world only appears stable because it's built on top of this shimmering ocean of uncertainty. Think of it like this. Reality isn't solid. It's a movie, a sequence of frames being projected by something deeper. Each moment of time is a snapshot created when observation locks down a possibility. Between those moments, the universe is pure potential, a blur of everything that could happen. That means your every choice, every thought, every act of attention literally shapes the universe's next frame. This isn't fantasy, it's the uncomfortable implication of quantum theory itself. The observer is part of the equation. Reality doesn't exist independently of observation, it includes it. If the laws of physics seem to bend, maybe it's because the universe isn't an object at all, but a relationship between the observer and the observed, between consciousness and creation. That could explain why the cosmos seems fine-tuned for life. Maybe life isn't an accident of physics. Maybe physics is an expression of life. Maybe consciousness and the universe emerged together, two sides of the same coin. And here's where it gets truly unsettling. What if the reason the universe seems to rewrite itself, as we saw before, is because consciousness keeps interacting with it, changing it, evolving it? That would make reality participatory. The universe wouldn't just exist out there, it would be co-created moment by moment through awareness. No wonder physicists are uneasy. The equations they've trusted their whole careers suddenly point towards something that sounds more like philosophy, or even spirituality. But they can't deny the data. Particles behave like they have memory. Systems change when observed. The past shifts depending on what's measured in the present. These aren't metaphors, they're experiments. Reality, it seems, isn't just weird. It's alive with interaction. The more we study it, the less we can separate the observer from the observed. The universe doesn't stand still for us to measure it. It responds, shifts, and transforms in real time. It's not a passive stage, it's a conversation. That conversation is happening everywhere, from the subatomic level to the vastness of space. Every photon, every atom, every heartbeat is part of the same endless dialogue between being and awareness. Maybe that's what the crisis in cosmology is really about. It's not just that our equations don't match the data. It's that our definition of reality itself might be wrong. We thought the universe was a machine. But what if it's more like a mind? And what if that mind, infinite, mysterious, and self-aware, is trying to tell us that we're part of it? We live by the clock. We count birthdays, deadlines, and years. We feel time rushing when we're anxious and crawling when we're bored. We imagine the past behind us and the future ahead, an endless line stretching forward. But what if that's completely wrong? What if time isn't flowing at all? Time isn't what we think. For centuries, humans believed time was like a river, carrying everything from birth to death, moment to moment, never stopping, never looping back. But modern physics paints a picture so different, so counterintuitive, it almost feels like an attack on our senses. According to the equations that govern the universe, time doesn't flow. It doesn't move. It simply is. Every moment, your childhood laughter, today's heartbeat, your final breath, already exists side by side, written into the structure of space-time like pages in a single massive book. The past, present, and future are all equally real. We just happen to be reading one page at a time. Physicists call this the block universe, a timeless cosmos where everything that has ever happened and will ever happen coexists. Einstein himself hinted at this when he wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." To most of us, that feels impossible. We feel time moving. We see the sun rise. We grow older. We remember yesterday, but not tomorrow. Surely something is flowing, something is changing. But that flow may not be out there in the universe. It may be inside us. Imagine a film reel. The entire movie exists at once. Every frame, every scene, already printed on the strip. The characters inside the film experience one frame at a time, unaware that their whole story is already complete. That's us. Our brains are the projectors, lighting up each frame of existence in sequence and calling that sequence time. But outside our perception, the entire film, our lives, our histories, even the future of the cosmos, may already exist in a single unchanging structure. This doesn't mean your choices aren't real. It just means they're already part of the script. The universe might not be moving forward. It might simply be there eternally, with you walking through it as consciousness unspools it moment by moment. Scientists once thought the arrow of time, the sense of direction from past to future, came from the laws of physics themselves. But here's the strange thing. Those laws don't care about direction. Gravity, electromagnetism, even quantum equations, they work the same whether time runs forward or backward. If you played the universe in reverse, the math would still check out. Nothing in the core structure of physics defines a past or a future. So where does time's arrow come from? The most accepted answer lies in entropy, the measure of disorder in a system. Entropy always increases. An egg can break, but a broken egg doesn't spontaneously reform. Smoke can spread, but never reassemble. Ice melts into water, but never the reverse. Not naturally, anyway. That steady increase in disorder gives us the illusion of flow. When entropy rises, we experience forward. But entropy isn't a force. It doesn't push time. It simply marks it. Like a cosmic thermometer, it records which direction the universe is moving in terms of complexity and chaos. In other words, time might not flow forward because of some fundamental cosmic law. It might feel that way only because our brains are wired to notice change. Here's where it gets even stranger. If time isn't flowing, then all our concepts of before and after might be mental constructs, shortcuts evolution gave us to survive. We experience time because our minds process sensory data in sequence. Memory becomes our internal clock, giving meaning to motion and cause. Without memory, even a fraction of it, the concept of past collapses. Think about it. The only reason you know you had breakfast this morning is because you remember it. But that memory exists now, in the present. You can't prove breakfast happened anywhere else except inside your mind at this very moment. That's why some physicists and philosophers believe time is emergent, not a fundamental property of the universe, but something that arises from how we observe it. If that's true, then time is like color. Color doesn't exist in nature. It's a sensation our brains create when light of different wavelengths hits our eyes. The physical world has only energy. Our perception adds meaning. Time, too, might be a translation. Our brain's best attempt to make sense of a reality that doesn't actually unfold. At this point, science and philosophy start to blur. If the block universe is real, then the future isn't waiting to be written. It's already there. Every joy, every heartbreak, every decision you'll ever make already exists, frozen in the fabric of space-time. You just haven't reached that frame yet. This idea can feel crushing or liberating. Crushing because it challenges the idea of free will. Liberating because it means nothing is ever truly lost. Your best memories, your most important moments, they're still there, alive in another corner of space-time, untouched by decay or time's erosion. In that view, death isn't an end. It's just the last frame your consciousness perceives, not a disappearance, but a transition into stillness. But there's another school of thought, one that refuses to let go of time's mystery. Some physicists think time might be more than an illusion, more than perception. They suggest it's a byproduct of something deeper, a kind of cosmic computation. Imagine the universe not as a fixed block, but as a system continuously calculating itself. Each quantum interaction, each exchange of energy, is like a tick of a universal clock, the universe updating its own state. In that case, what we call the flow of time might be the result of the universe running its code, frame by frame, moment by moment. From that perspective, you are part of the computation, a conscious process woven into the larger flow. And here's the twist. As our awareness expands, as we study time, meditate on it, question it, we might actually be altering how it unfolds. Some experiments in quantum physics hint that observation affects not only what we see, but when we see it. A choice made now can retroactively affect what happened before. In that sense, the future doesn't just follow the past, it interacts with it. So which is it? Is time an illusion, a perception, or a living process? Maybe it's all three. Maybe time isn't something we move through. Maybe it's something that moves through us. A vast ocean of possibilities flowing into consciousness one drop at a time. Every tick of a clock, every heartbeat, every sunrise is the universe whispering, "This is the moment." And maybe, in the grandest truth of all, every moment, from the birth of stars to your quiet breath right now, is happening together, all at once. If you've ever stared at an old photo of yourself and felt that strange ache, that sudden awareness of how much has changed, you've experienced the mystery that even physics can't fully explain. Time. We live it, we measure it, we chase it. And yet, when physicists look closely, time itself begins to fall apart. Einstein dealt the first blow. His theory of relativity revealed that time isn't universal. It bends, stretches, and slows depending on how fast you move or how close you are to a massive object. Time on a spaceship near the speed of light doesn't move the same as time on Earth. Two people can live through completely different amounts of time depending on their motion, and both experiences are equally real. It was a shattering idea. Time wasn't a single cosmic beat marking the universe's rhythm. It was elastic, personal, woven into the fabric of space itself. Together, they formed what Einstein called space-time, a vast, four-dimensional block where all events, from the birth of stars to your next heartbeat, coexist. It's unsettling. It turns time from a living stream into a frozen landscape. The flow we feel may not be a property of the universe. It may be a property of our minds. That realization opens the door to something even stranger. Maybe time isn't fundamental at all. Maybe it emerges from something deeper. Modern physics, particularly quantum gravity and thermodynamics, is beginning to suggest exactly that. Time, some researchers argue, might not exist at the smallest scales of reality. Beneath the smooth continuum we perceive lies a realm of timeless interactions. Particles don't tick through moments. They simply are. It's only when we step back, when vast numbers of interactions occur together, that time begins to emerge, like temperature does when trillions of particles move together in chaos. This connection between time and entropy, the measure of disorder, is one of the most profound in all of science. Entropy tends to increase. Eggs crack but don't uncrack. Smoke spreads but doesn't gather itself back into a cigar. This one-way rise of disorder gives us the arrow of time. It's why we remember the past but not the future. Why coffee cools instead of reheating itself spontaneously. But here's the kicker. The laws of physics themselves don't require this arrow. On the most fundamental level, the equations that describe particles are time-symmetric. They don't care if time goes forward or backward. So why then do we feel the difference so strongly? Why do we experience time as a march forward rather than a static block? Some scientists argue it's simply perception. Our brains are built to process information in one direction, from lower entropy to higher. Memory, consciousness, and decision-making all rely on the arrow that entropy provides. To us, that makes time feel like a flow. But that sensation may just be a biological illusion, a trick of perspective played by an otherwise timeless universe. Others take it further. Perhaps what we call now doesn't exist objectively at all. It's just the point our consciousness happens to be observing. Like a flashlight moving along the pages of a book, our awareness illuminates one moment at a time, giving the illusion of motion. But the book, the entire timeline, is already written. This idea shakes everything we think we know about existence. If time is an illusion, what does that mean for cause and effect? For choice? For free will? Think about it. If the future already exists just as solidly as the past, then in some sense, every decision you'll ever make has already been made. Every victory, every heartbreak, every sunrise and sunset in your life is already there, waiting. You're not moving toward your future, you're already living within it. Some scientists find comfort in that, a universe that's stable and complete. Others find it terrifying. It strips away the sense of agency, of progress, of hope. But perhaps that discomfort comes from misunderstanding what frozen really means. Because even if time is an illusion, it's a necessary one. It's the stage upon which our consciousness performs. Without time, there's no story, no growth, no change, no learning. Time may not exist at the deepest physical level, but it might be real enough at ours. Just as a rainbow isn't an object but an interaction between sunlight and perception, time might be the rainbow of reality, something that arises when the universe looks at itself through the lens of awareness. And yet, the mystery deepens when we look further into quantum physics. In some interpretations, the universe doesn't have a definite history until it's observed. That means the past itself could be malleable, shaped by measurements in the present. It's as though time can ripple backward, reshaping events to fit new information. If that's true, the arrow of time isn't just an illusion, it's a negotiation, a conversation between the observer and the observed. So when we say time flows, maybe we're misunderstanding it. Time doesn't flow. We do. We flow through states of awareness, creating the sense of progression as our consciousness encounters each moment in turn. Maybe that's why, no matter how deep the equations go, physicists can't fully erase the human experience of time. Because time is where physics meets perception, where the external and internal universes collide. At the end of the day, the illusion of time is perhaps the most beautiful trick the universe ever played. It lets something eternal pretend to move. It lets something infinite experience change. The physicists may tell us time doesn't exist, but as long as hearts beat and memories fade, we'll keep feeling it. And maybe that's the whole point. Because even if the flow of time isn't real, what it creates, love, loss, meaning, life, most certainly is. The end of time hypothesis. Imagine waking up tomorrow and finding that time has stopped. Not frozen, not slowed, but stopped existing altogether. The clocks are still ticking, but they no longer mean anything. The sun still rises, but not because it's after night. Because there's no before or after left. Everything that ever was, is, or will be exists right now, together, layered like pages in a book that's never read front to back. That's the essence of one of the most unsettling and fascinating ideas in modern physics: the end of time. For centuries, we've thought of time as the backbone of reality. Everything happens in time: the birth of a star, the fall of an apple, your heartbeat right this moment. But what if that's wrong? What if time isn't a fundamental feature of the universe, but a convenient illusion, a way for our minds to make sense of change? This radical view is the life's work of Julian Barbour, a British physicist and philosopher who dares to suggest that time, as we know it, doesn't exist at all. In his universe, there's no cosmic clock ticking in the background, no flow from past to future, no moment giving way to the next. Instead, reality is made of an endless collection of nows, timeless snapshots of the universe in all its possible states. Barbour calls this vast collection Platonia, named after Plato's world of perfect eternal forms. In Platonia, every possible arrangement of the universe, every position of every particle, every configuration of every galaxy, every heartbeat you've ever had, exists simultaneously. Nothing moves from one state to another. Movement itself is just an illusion created when one snapshot relates to another in our perception. In other words, change is real, but time is not. It's an idea that sounds like poetry until you realize it's also physics. Barbour's theory comes from a simple but powerful question. If the laws of physics are timeless, why do we need time at all? When scientists describe how things move, a ball rolling, a planet orbiting, an electron spinning, they use equations that don't require a ticking clock. They only describe relationships between states. One configuration leads to another, and that's enough. The flow of time doesn't appear anywhere in the math. It's something we've imposed, like adding subtitles to a silent movie. In Barbour's picture, every frame of the universe, every configuration of matter, exists independently, complete and self-contained. You at 5 years old, you right now, you 20 years from now, all exist as separate frames within the grand library of Platonia. You don't move from one to the other, your consciousness simply experiences one now that contains traces of others, creating the illusion of a timeline. Think of it like flipping through photos on your phone. Each picture is static, but when you arrange them in order, when your brain connects them, a story appears. That story feels like time, but it's not the photos that move, it's you. To many physicists, this is deeply unsettling. Time isn't just part of our daily lives. It's woven into everything we measure: clocks, calendars, lifetimes, decay rates, orbits. The universe without time feels like a novel without pages. But Barbour argues that it's precisely this emotional attachment that blinds us. We think time flows because we do. Our memories form in sequence, our bodies age, our thoughts appear and fade. But what if that sense of flow is a trick of memory, a side effect of how our brains store information? Barbour points to something called a time capsule, a configuration of the universe that contains traces of what we interpret as the past. For instance, a fossil is a time capsule of an ancient creature. Your memory is a capsule of your previous states. In Platonia, these capsules exist all at once. When your consciousness aligns with one particular configuration, say, a now that contains memories of yesterday, you feel like you've moved forward in time, but you haven't. You've just landed on a page that remembers others. It's a breathtakingly strange concept that the passage of time is nothing more than the universe remembering itself. If this sounds like science fiction, it's worth remembering that Barbour isn't alone. The equations of quantum gravity, attempts to unify Einstein's relativity with quantum mechanics, often produce models that omit time entirely. In one of these, known as the Wheeler-DeWitt equation, the universe simply is. There's no then or now, no unfolding cosmic film reel. Everything that can exist does exist, timelessly. In this view, asking what happened before the Big Bang is meaningless. There is no before. The Big Bang isn't the start of time. It's one of countless static configurations within Platonia. The universe didn't begin. It just is. This turns our understanding of existence upside down. If time doesn't exist, then the universe isn't a story. It's a sculpture. Every event, every life, every thought is carved into the eternal structure of reality. From our limited perspective inside it, we see only a sliver, a slice that feels like the present. But from the outside, if there even is an outside, it's all there, forever. And yet, this timeless universe isn't lifeless. It's full of potential meaning. If everything exists at once, then death isn't an ending. It's simply another part of the pattern. The moments of joy, pain, love, and discovery that define your life are eternally present somewhere within the fabric of Platonia. You're not moving toward oblivion. You're part of an infinite collection of nows, all equally real, all equally alive. In a strange way, Barber's vision of the universe offers comfort. We spend our lives running from the future, regretting the past, clinging to the present. But what if none of it ever really goes away? What if every smile, every laugh, every goodbye exists forever, frozen in the grand structure of existence? Time, as we know it, might end, but being doesn't. Still, the human mind rebels against this. We feel time. We see it in the mirror, in the turning of seasons, in the loss and renewal that shape our lives. To accept a timeless reality is to admit that everything we experience, progress, change, history, is a kind of illusion. It's like realizing the movie you've been crying over was just light on a wall. Yet maybe that's what makes the illusion so powerful. Maybe the universe needs time to make meaning. Just because something is an illusion doesn't mean it's unimportant. The rainbow may not exist as a solid object, but its beauty is real. The song of time, even if it's only a trick of perception, still gives rhythm to existence. Perhaps time isn't the problem. Perhaps it's the language reality uses to speak to us. Barber himself once said, "Change exists and we experience it, but change doesn't need time." Maybe that's the key. We don't live in time, we live through change. Time is the story we tell ourselves about that change, the heartbeat of consciousness echoing through the timeless void. And if that's true, then the end of time isn't the end of existence at all. It's the moment we realize that everything we've ever been, everything we'll ever be, already is. What if the universe never truly began and will never truly end? Loops, symmetry, and rebirth. This idea, as wild as it sounds, isn't just philosophy anymore. It's quietly creeping back into serious science. For centuries, cosmologists believed in a one-way story, a universe born from a singular Big Bang, expanding endlessly into cold emptiness. But as the equations start to misbehave and the data begins to whisper contradictions, a new possibility is emerging. Maybe the universe doesn't march forward in a straight line at all. Maybe it moves in loops. To most of us, time feels like a line, a beginning, a middle, and an end. But many of nature's patterns disagree. Look closer, and you'll see that loops are everywhere. The planets orbit the sun in repeating cycles. Seasons rise and fall, atoms vibrate in rhythmic waves. Even life itself operates in cycles: growth, decay, renewal. So why would the universe, the biggest system of all, be any different? For years, scientists dismissed the idea of a cyclical cosmos as myth or metaphor, something belonging to ancient philosophies like the Hindu concept of eternal creation and destruction, or the Stoic notion of the great year. But then came the cracks in the Standard Model, the inconsistencies in how galaxies form, how cosmic expansion behaves, how entropy evolves. Those cracks forced physicists to consider that maybe, just maybe, the universe isn't a one-time event. One of the most fascinating modern versions of this idea comes from a theory called loop quantum gravity. Unlike string theory, which imagines tiny vibrating strings as the building blocks of matter, loop quantum gravity looks directly at space and time themselves. It says the fabric of the universe isn't smooth. It's made up of unimaginably tiny loops of energy, woven together like threads in a cosmic tapestry. And here's where it gets astonishing. When you zoom all the way down, those loops behave in a way that could erase the very concept of a singularity, the infinite, impossible beginning that the Big Bang supposedly sprang from. Instead of a beginning, loop quantum gravity paints a picture of bounce. Imagine the universe contracting inward over trillions of years, matter drawn together by gravity, everything heating, compressing, folding inward. Normally, this process should end in disaster, an infinite density, a breakdown of physics, a before which nothing exists. But according to this theory, the loops of quantum gravity resist that collapse. They have a kind of elastic limit. When the universe becomes dense enough, the loops push back, creating a rebound, a cosmic exhale following an infinite inhale. In other words, before our Big Bang, there may have been another universe, and before that one, another, and another still. The universe may be eternal, not in static stillness, but in endless rhythm. This cosmic bounce theory isn't just poetic, it's mathematical. Equations in loop quantum cosmology suggest that time doesn't vanish at the Big Bang, it simply flips direction. What we call the beginning might just be the end of a previous cosmic phase. The death of one universe becomes the birth cry of another. And this idea has a haunting symmetry. Think of breathing, inhale, exhale. Think of a heartbeat, pulse, rest, pulse again. Think of stars, born from clouds of dust, burning bright, collapsing, scattering their ashes, which become the seeds for new stars. Everywhere we look, the universe is recycling itself. So why should reality itself be any different? If the cosmic bounce is real, then time is circular, not linear. Every event, every atom, every pattern might return in some new configuration. The universe doesn't end, it resets. But this raises deeper questions, philosophical ones that even physicists can't avoid. If the universe loops endlessly, does that mean everything repeats? Are we living a life that has happened an infinite number of times before? Are we destined to live it again? This notion, known as eternal recurrence, fascinated thinkers from the ancient Egyptians to Friedrich Nietzsche. Nietzsche called it the heaviest burden, the idea that you must live your life again and again, exactly as it is, with every joy and sorrow repeating forever. But through the lens of modern physics, it's not about punishment or destiny, it's about structure. If the universe operates in cycles, then perhaps each cycle isn't identical, but rhyming. Each rebirth might carry the echoes of the last, just as a new season resembles the one before, but never repeats it perfectly. In some models, tiny quantum differences between one cycle and the next could grow into massive variations, creating universes that evolve differently each time. One loop might produce galaxies just like ours. Another might produce something unimaginable. We may be part of an infinite family of universes, each born from the ashes of the previous one. And it gets stranger still. In cyclic models, time might not be infinite in both directions. It might be bounded by symmetry. Some physicists propose that the universe could reach a mirror point, a perfect balance between expansion and contraction, where time, as we know it, reverses. On one side of that point, entropy increases. On the other, it decreases. What looks to us like the past might actually be the future of another universe flowing the opposite way. Imagine that. Somewhere on the other side of the Big Bang, another version of reality might be unfolding. Not ahead of us, but behind us. With its own galaxies, its own light, its own beings asking the same questions we are, wondering why time flows the way it does. Perhaps to them, we're the mirror universe. The beauty of this possibility isn't just in its symmetry, but in its message. It means the universe is resilient. It doesn't vanish into nothing. It transforms. It remembers how to rebuild itself. Even death, cosmic, planetary, or personal, becomes part of a rhythm that never truly ends. Every collapse is just a prelude to expansion. Every ending, a disguised beginning. The ancient philosophers who spoke of the eternal return may have been closer to the truth than they realized. The universe might be a phoenix, burning itself to ashes again and again, only to rise anew. So when scientists talk about loops, symmetry, and rebirth, they're not just describing equations. They're describing a cosmic heartbeat, a pulse that never stops. And if you listen closely enough, you might realize that pulse is everywhere, in galaxies, in oceans, in your own chest. Because maybe the universe isn't dying at all, maybe it's simply breathing. Reality as a mirror of mind. For most of human history, we've believed the universe existed out there, a vast, indifferent stage upon which our brief lives unfold. The stars were objects, the galaxies distant fires, and the laws of physics were written in stone long before we arrived. Yet now, as science stands in the twilight between understanding and awe, something unnerving is emerging from the data and equations. The possibility that the universe is not separate from us. The idea once dismissed as mystical or poetic, that consciousness and cosmos reflect each other, is beginning to echo again through laboratories, observatories, and conference halls. It's as if, after mapping the farthest edges of space and the smallest building blocks of matter, physicists have turned around and found their own reflection staring back. This is not a metaphor. It's a quiet but growing recognition that observation itself may play a role in shaping what we call reality. It starts with a puzzle, one so familiar that scientists almost stopped seeing how strange it truly was. Every measurement from the path of an electron to the brightness of a distant quasar depends on an observer. Quantum mechanics made this explicit a century ago. Particles don't seem to have definite properties until they're measured. Before that moment, they exist only as probabilities, shadows of potentiality. For decades, physicists pushed this mystery aside. Shut up and calculate, the saying went. The math worked and the universe behaved, mostly. But the cracks have widened. When telescopes detect variations in the cosmic microwave background, the afterglow of the Big Bang, some researchers now argue that what we're seeing might depend subtly on how we look. The observer, once assumed passive, seems woven into the fabric of cosmic information itself. If consciousness plays a role in reality, then the universe is not just a physical phenomenon, it's participatory. We aren't outside of it, we're inside it, and perhaps even part of its self-awareness. Philosophers have whispered this truth for centuries. From the ancient Upanishads that declared the self and the universe are one, to the words of Carl Jung, who said, "Who looks outside dreams, who looks inside awakens." But science, ever cautious, has now come full circle to where philosophy began. Quantum information theorists propose that consciousness could be an emergent property of the universe's information processing. In this view, the cosmos is not a cold, empty expanse. It's a vast field of computation, an endless exchange of bits and possibilities. Each conscious mind, yours, mine, the ants on the ground, and perhaps even the stars themselves, is a node in that network. The universe might not simply be observed by consciousness, it might become conscious through us. This is not sentimental mysticism. It's mathematics, hinting at introspection. The equations describing entanglement, the eerie connectedness of particles across distance, mirror the way experiences and emotions entangle in the mind. The same wave-particle duality that baffles physicists has parallels in human awareness, which can hold contradictions, probabilities, and paradoxes without collapsing. Maybe consciousness is not a fluke of biology, but a fundamental property of existence itself. Imagine this. The universe didn't begin with the Big Bang as an explosion in space. It began as a burst of awareness within a void. Space and time unfolded as that awareness differentiated itself into galaxies, atoms, and life. Every star that forms, every species that evolves, is the cosmos learning a little more about itself. In that sense, the human mind is not an accident of evolution. It is a mirror through which the universe finally sees its own reflection. Some scientists call this panpsychism, the idea that consciousness is not confined to brains, but exists in varying degrees throughout all of reality. Others describe it as the participatory universe, a concept introduced by physicist John Archibald Wheeler, who argued that the universe only becomes real when observed. The more we study the fabric of space-time, the more it seems to behave like a vast neural network, a mind in motion. This convergence between mind and cosmos doesn't mean science has surrendered to mysticism. It means that the divide between them might never have existed in the first place. The boundaries we draw between matter and mind, observer and observed, may be illusions born from limited perception. When we gaze through telescopes, we're looking backward in time, billions of years into the past. But in that act of looking, something intimate occurs. The universe perceives itself through human eyes. Perhaps that's why so many physicists and philosophers describe a quiet, inexplicable awe when confronted with the stars. It's not just beauty, it's recognition. A faint sense that what's out there and what's in here are not two different things. Yet this idea is not merely comforting, it's destabilizing. If consciousness and reality are intertwined, then every scientific equation we've built on objectivity might need rewriting. It suggests that truth is not something found in the universe, but something co-created between the universe and the observer. Reality then becomes a kind of feedback loop, a dialogue between awareness and matter, perception and probability. The deeper we look, the more the mirror bends back toward us. And maybe that's the real reason scientists whisper that something is very wrong with our universe. Not because it's breaking, but because it's waking up. A few researchers take it further still. They propose that consciousness doesn't just mirror the universe, it drives it. The collapse of a quantum wave, the direction of time, even the emergence of space itself might depend on awareness acting as a cosmic catalyst. If so, then every thought, every act of noticing, ripples through reality in ways we cannot yet measure. The mind becomes not a spectator, but a participant in the grand unfolding of existence. When seen that way, the universe isn't a machine running on blind laws, it's a living conversation. A story being told in matter and light, energy and silence, and every observer, from the smallest organism to the largest galaxy, is both reader and writer. So when scientists say something is wrong with our universe, maybe it's not a flaw in the code, maybe it's the beginning of recognition, a realization that the cosmos and consciousness are two sides of the same coin. That reality, in all its strangeness, might be less like a laboratory experiment and more like a dream that is learning to dream itself. And perhaps that's why we're here, not to solve the universe, but to witness it becoming aware of its own reflection. Absolutely. Here's a 960-plus word continuation of part the 14th, The Cosmic Reckoning, titled The Universe Looking Back at Us. There's a strange feeling that comes with staring up at the night sky, a stillness that hums with something almost personal. You might not be able to name it, but it's there. That quiet sense that the stars aren't just out there, glittering in emptiness. They're somehow aware that you're looking. For centuries, humans have treated the universe as an object to be studied, vast, indifferent, mechanical. But what if, through every telescope we build, through every equation we solve, the universe is actually studying us? It's a wild thought, but not a new one. The deeper science peers into the cosmos, the more it seems to find its own reflection staring back. It's as if we're caught in a hall of mirrors, light bouncing endlessly between consciousness and creation. And with every new discovery, the universe seems to whisper, "I see you too." Think about what it took for the universe to build a pair of eyes, human eyes, capable of seeing itself. 13 billion years of cosmic alchemy. Stars lived and died to forge the atoms in your retina. Supernovas scattered the carbon, nitrogen, and oxygen that became your bones and blood. And after an eternity of silence, those ingredients organized into something that could finally look back. You are made of the same elements as the stars you're staring at. When you gaze at the night sky, it isn't one thing observing another. It's the cosmos looking at its own reflection. That realization, that we are the universe made conscious of itself, might be the most profound discovery humanity has ever stumbled upon. Not because it flatters us, but because it humbles us. It means that the story of creation didn't end with the Big Bang. It's still unfolding inside our minds. Carl Sagan once said, "We are a way for the cosmos to know itself." He wasn't speaking metaphorically. He was describing a truth that modern cosmology keeps accidentally uncovering. Consciousness is not a visitor to the universe. It's one of its most extraordinary products. Every breakthrough, every equation, every photograph from a deep space telescope, these are not just acts of curiosity, they are acts of remembering. When the Hubble Space Telescope captured the image known as the Deep Field, a patch of sky that looked empty but revealed thousands of galaxies, humanity gasped. It was as if the universe had lifted its own veil, showing us how infinite and fertile it truly was. That moment wasn't just discovery, it was recognition. When Einstein wrote his equations, when Newton saw the apple fall, when Rosalind Franklin's X-ray revealed the spiral of DNA, each of those moments was the cosmos recognizing something about itself. Matter understanding matter, life decoding life. The observer and the observed no longer separate but joined in a single act of awareness. Science has always tried to remove the human element, to be objective, detached, analytical. But perhaps that's been the illusion all along. Because what is the scientific method if not the universe's own intelligence trying to understand its design? When we run experiments, we're not detached spectators. We're neurons firing inside the cosmic brain. The more we explore, the clearer the pattern becomes. The universe mirrors us at every scale. Atoms orbit their nuclei like planets around suns. Galaxies cluster like neural networks. The cosmic web, when visualized, looks startlingly like a map of the human brain. These resemblances aren't coincidences. They hint at a fractal intelligence, a self-similarity that threads through reality from the smallest quantum field to the largest supercluster. It's as if creation has one recurring signature, one blueprint that repeats itself endlessly, adjusting scale but never principle. And if the cosmos and consciousness share the same geometry, then maybe they share the same purpose too. To know, to perceive, to experience. We think of the universe as a vast theater, but maybe it's more like a single organism, growing, feeling, evolving through us. Our curiosity, our art, our longing for meaning, these may not be human quirks, but the natural expressions of the universe's instinct to know itself. There must have been a first moment, somewhere in the deep past, when the cosmos achieved self-awareness for the very first time. Maybe it was when the first living cell twitched. Maybe it was when the first creature looked up at the stars and wondered. That moment, the first question, might have been the birth of consciousness as a cosmic force. From that instant, something changed. The universe was no longer just existing, it was reflecting. You can almost imagine it, a spark of thought rippling backward through space-time, as if the cosmos realized it was alive. Every human question since then: where did we come from? Why are we here? What is out there? Is the echo of that first awakening. And maybe that's why discovery never satisfies us for long, because the universe's hunger to know itself is infinite, and we are the mouth it uses to ask. Yet there's a strange twist. Every time we think we've reached the edge of understanding, the boundary shifts. The more we learn, the more mystery we uncover. It's as if the act of seeing changes what can be seen, the cosmic equivalent of the quantum observer effect. When we discovered atoms, we found subatomic particles. When we mapped galaxies, we found dark matter. When we measured cosmic expansion, we found dark energy. Every layer of discovery opens a deeper question, as if the universe is gently teasing us towards something larger, something beyond comprehension. It's a mix of knowledge and mystery, a divine game of hide and seek, and the further we look, the more we realize that perhaps the universe doesn't want to be solved. Maybe it wants to be experienced. Maybe the purpose of consciousness isn't to conquer mystery, but to share it. If the universe is looking back at itself through us, what does that make humanity? Tiny, yes. Fragile, absolutely. But also profoundly sacred. We are the lenses through which existence perceives its own unfolding. Every act of kindness, every discovery, every spark of love or creativity, these are ways the cosmos expresses itself inwardly. When you stare into someone's eyes and see yourself reflected there, you are witnessing a universal truth on the smallest possible scale. Two minds, two galaxies of thought, recognizing the same spark of awareness that has always burned at the heart of reality. And if consciousness truly mirrors the cosmos, then perhaps humanity isn't a final form at all, but a phase. Maybe evolution is the universe's way of refining its vision, of sharpening its own awareness. And perhaps the next leap won't be technological or biological, but spiritual. Not in the religious sense, but in the sense of unity. Realizing that everything we touch, everything we study, is another version of ourselves. Imagine an artist painting without knowing who they are. They paint the stars, the atoms, the laws of physics, and only when the canvas is almost complete do they realize the portrait is of themselves. That artist is the universe, and we are the brush in its hand. Every discovery adds a stroke to the cosmic self-portrait. Every question deepens the shadows, refines the colors, brings the image into focus. But the painting will never be finished, because the moment the universe fully understands itself, there would be nothing left to discover. So it keeps going, creating new eyes, new minds, new questions. Each one another mirror, another reflection, another chance to see from a slightly different angle. And that might be the truest beauty of existence, that we are not just witnesses of the universe's grandeur. We are its awareness, its art, and its wonder, looking back upon itself. The mystery that defines us. There comes a point in every great pursuit of knowledge, every experiment, every theory, every sleepless night in the lab, when a scientist must face something they can't measure. Not an error, not a gap in data, but something deeper. A silence that stares back. That silence is mystery. It's what hums beneath the equations, behind the galaxies, and inside the human heart. It's the moment when you realize that no matter how far we reach, there's always something beyond the horizon, something that refuses to be reduced to numbers. And maybe that's the point, because science, for all its brilliance, is not here to erase mystery. It's here to illuminate it, to hold it up, trembling and glowing, and whisper, "Look how beautiful not knowing can be." For centuries, humanity has tried to dissect the universe into certainty. We built telescopes to peer into the void, microscopes to dive into the small, equations to lock reality into logic. We've mapped the DNA of life, harnessed the power of atoms, even captured the light of galaxies born before Earth itself. And yet, the more we discover, the stranger everything becomes. The quantum world refuses to behave. Time bends and ripples. Space expands into something we can't quite describe. The closer we get to truth, the less it looks like a straight line, and the more it feels like a spiral. Science has not conquered mystery. It has only made it more sophisticated. Every answer we find deepens the riddle. When the first humans looked at the stars, they saw gods and spirits. Today we see plasma and gravity, but the feeling is the same. That trembling awe before something that seems alive, aware, and endless. Maybe the greatest misunderstanding of our age is thinking that wonder and science are opposites. They are not enemies, they are partners. Wonder is where science begins, and where it must inevitably return. There's a temptation, especially among scientists facing contradictions and anomalies, to say that the universe is broken, that something has gone wrong with our model, our math, our understanding. But what if the universe isn't broken at all? What if it's just infinitely stranger than we have words for? When the cosmos behaves in ways that defy our predictions, when light bends in impossible arcs, when particles flicker between realities, when time itself stretches, that isn't a failure. It's the universe reminding us that it doesn't exist to fit inside our minds. It's bigger, wilder, beyond the reach of even our most daring theories. It's not that the laws of nature are inconsistent. It's that they are deeper than what we've written down. Maybe there are dimensions beyond dimensions, realities stacked like mirrors, causes and effects that run both ways. Maybe what we call paradox is just truth viewed from the wrong angle. We keep trying to simplify the cosmos, but perhaps it's not meant to be simple. Perhaps complexity is the law. In a world obsessed with answers, we forget how powerful it is to admit ignorance. I don't know is not a failure. It's the beginning of discovery. It's the seed of every breakthrough. Every time a scientist has looked at the universe and said, "That's strange," something revolutionary has followed. When Newton saw the apple fall, he didn't know why. When Einstein questioned the speed of light, he didn't know what he was about to change. When quantum physicists saw particles behaving like waves, they were baffled. And that confusion opened the door to modern technology. Confusion is sacred, because it's the moment the universe challenges us to grow. The greatest scientists were not those who had all the answers, but those who could live comfortably in uncertainty, who could walk through darkness guided only by curiosity and wonder. And in that way, science and spirituality are not so different. Both are languages of reverence. Both are ways of kneeling before the unknown. If the universe truly mirrors the mind, then perhaps mystery is not something outside us. It's woven into who we are. Maybe that's why, even after centuries of progress, we still feel the same ache when we look at the stars. That ache is not ignorance, it's recognition. Because deep down, we know we are made from that same mystery. We are not standing apart from the cosmos, asking questions about it. We are the cosmos, asking questions about itself, and maybe, just maybe, the reason we can never fully understand the universe is because we are inside it. You can't step outside the mirror to see the whole reflection. We can only glimpse fragments, light and shadow, matter and thought, and each fragment points to something vast and unseen. That's what makes the search for truth so beautiful. It will never end. There will always be more to find, more to feel, more to know. And maybe eternity is not a place, but that endless process of learning, of reaching, of wondering. There's a quiet shift happening in science. A generation ago, to speak of mystery was to risk being called unscientific. But now the best minds are admitting something profound. The universe might not be solvable, and that's okay. The purpose of science may not be to close the book on mystery, but to keep turning its pages. Each discovery isn't an ending, but a deeper beginning. As physicist Richard Feynman once said, "I think it's much more interesting to live not knowing than to have answers which might be wrong." That's the essence of wonder, to stay open even when you don't understand. To walk into the dark and trust that curiosity is enough light to move forward. That's what defines us as human beings. Not the knowledge we've gathered, but the awe that keeps us searching. Imagine standing on the shore of the universe. Every discovery is a wave that laps at your feet, and behind it stretches an ocean without end. You can spend a lifetime charting the currents, collecting samples, building maps, but no map will ever contain the sea. And that's the gift. The universe doesn't need to be tamed or solved. It only asks that we keep exploring, with humility, with awe, with eyes wide open. Because maybe the goal of science isn't to understand everything. Maybe it's to remember that we are part of something far greater than understanding. A mystery vast enough to hold galaxies, and gentle enough to hold you. So when scientists say, "Something is very wrong with our universe," perhaps what they really mean is, something is wonderfully, beautifully beyond us. The universe is not broken, it's alive. It grows stranger, deeper, more intricate the closer we look. And in that strangeness, it reveals the truest thing about ourselves. That we too are mysteries in motion, that curiosity is our native language. That awe, is not weakness. It is intelligence recognizing its limits. And maybe, in the end, that's what it means to be human. To live suspended between knowledge and wonder, forever reaching toward a universe that will always, mercifully, remain just out of reach. Because it is in that unreachable space, that vast, sacred unknown, that we finally find meaning. And it is there, in that mystery, that the universe keeps looking back at us and smiling.